On the morning of September 18th, 2025, the ground beneath the Pacific Ocean rose and fell with a violence that shook seismometers across half the world. Off the coast of Russia's Kamchatka Peninsula, a magnitude 7.8 earthquake ripped through a fault line that had been locked in silence for decades. In less than 3 minutes, billions of tons of rock shifted, releasing energy equivalent to multiple nuclear arsenals. Fishermen far out at sea felt their boats buck, as if tossed by an invisible hand. In towns, hundreds of kilometers away, windows rattled, dogs howled, and old men shook their heads knowingly, muttering that the earth had decided to breathe again. Yet what made this earthquake different was not simply its size. Earthquakes of this magnitude, while dramatic, are part of Kamchatka's tragic history. What made it extraordinary was its timing. Just 3 days earlier, on September 15th, the Earth had been struck not from below, but from above. A G3 geomagnetic storm, born from the Sun's restless surface, had crashed into our planet's magnetic shield. Auroras flared as far south as Colorado, painting the night sky with ghostly green curtains. Power companies scrambled to monitor transformers. Airlines rerouted flights to avoid radio blackouts. And amateur stargazers marveled at shimmering skies that normally belong only to the Arctic. 2 events, one from the deep belly of the Earth, the other from the blazing furnace of the Sunday separated by 72 hours, linked only by coincidence or so, most scientists would say. But for others, the overlap was enough to raise a troubling question. What if they were not isolated? What if Earth's crust and the Sun's outbursts were dancing to the same hidden rhythm? The mind resists such connections. We are taught to compartmentalize. Earthquakes belong to geology. Geomagnetic storms belong to astrophysics. And comets are the toys of astronomers staring through long lenses in mountain observatories. But sometimes, when events crowd too close together, the categories blur. We begin to sense a larger pattern, as if a hidden conductor were guiding disparate instruments in a symphony we only half understand. That sense of orchestration grows when we add the third presence that loomed silently in the background. Hurtling through interstellar space, long before humans learned to name themselves, is an object catalogued as C, divided by 2025 N, 1, better known as 3, I, divided by Atlas. It is only the third confirmed interstellar visitor in human history, following the enigmatic Oumuamua and the more conventional Comet 2, I divided by Borisov. Unlike them, Atlas is already awake, glowing with a coma half the size of the Sun itself. A traveler from between the stars, entering a solar system at a moment of maximum turbulence. 3 players then, the trembling Earth, the awakening Sun, and the alien wanderer. Their alignment is not literal. They are not lined up neatly like billiard balls in space. The alignment is symbolic, temporal, experiential. Earth shakes. The Sun flares. A foreign body approaches. Together, they force us to confront the possibility that our world is less isolated, less insulated than we like to imagine. In the quiet hours of night, when auroras paint the sky and aftershocks ripple through sleeping cities, such thoughts do not seem so far-fetched. What if the magnetic storms that ripple through Earth's atmosphere also ripple through its crust? What if tectonic plates, already groaning under immense pressure, are nudged toward release by invisible currents flowing through the mantle? What if an interstellar comet, dragging a sphere of ionized gas larger than any planet, alters the electromagnetic balance of the heliosphere in ways we cannot yet predict? These questions have no easy answers. Mainstream science is careful, cautious, and rightly so. The United States Geological Survey will tell you that earthquakes arise from tectonic forces alone, the slow grinding of plates that cover our planet like a broken eggshell. Solar physicists will tell you that geomagnetic storms light the skies and disrupt satellites, but they do not move continents. Astronomers will tell you that comets are passive visitors, spectacular but harmless. And yet, if you listen closely, you will hear in their voices a hesitation. Not everything is understood. Not every pattern has been dismissed. In that hesitation lies the space for wonder. This documentary does not claim to know the truth. It does not insist that geomagnetic storms cause earthquakes or that comets whisper to tectonic plates. What it does is linger in the mystery, exploring the possibility that our planet is part of a larger, interconnected web of forces. It invites you to drift with these ideas as you drift towards sleep, not to believe, but to imagine. Close your eyes now, if you like. Picture the Kamchatka Peninsula as seen from above, jagged mountains, smoking volcanoes, endless stretches of sea ice drifting offshore. Beneath that landscape, the Pacific Plate dives beneath the Eurasian Plate, building stress, century after century, until it finally snaps. Now picture the sun, not as the round yellow disk from children's drawings, but as a boiling sphere of plasma, magnetic fields twisting and snapping, flinging rivers of charged particles into space. And then, beyond them both, picture Atlas, a tiny icy nucleus surrounded by a shimmering cloud that could swallow dozens of Earths, gliding silently toward the inner solar system. Each image is clear on its own. Together, they form a triptych, a cosmic painting where Earth, Sun, and comet each hold a corner. Somewhere in the overlap between them, a story is unfolding. The details are not yet visible, but the outlines shimmer like aurora against the night. You may ask, why now? Why in 2025 do these events cluster together? The scientific mind answers with coincidence. The Earth's crust releases stress on its own schedule. The Sun follows its 11-year heartbeat. Comets come when their orbits bring them, nothing more. And perhaps that is true. Perhaps coincidence is the only explanation we need. But coincidence itself is a kind of pattern, a reminder that even random events must occur somewhere, sometime. When they occur together, we cannot help but wonder. In that wonder lies the seed of myth. Ancient peoples would have had no hesitation linking quake, storm, and comet. To them, the gods were speaking, warning, promising. We moderns smile at such myths, but are we so different? We, too, seek meaning in the timing of events. We, too, ask whether the cosmos is whispering to us. So let this be the prelude to our journey. In the chapters ahead, we will move carefully through data and speculation, through seismic catalogues and solar wind charts, through plasma tails and coronal holes. We will respect the boundaries of science, while also honoring the human hunger for pattern. We will consider the possibility that the ground beneath our feet and the sky above our heads are not separate theaters, but parts of the same stage. For now, rest with the image of two shocks in 3 days. The sun awakening, the earth trembling, the comet approaching. 3 notes struck in quick succession. Coincidence, perhaps, or the opening chords of a symphony we have only just begun to hear. The sun has always been both our most familiar companion and our greatest enigma. Every morning, it rises in the east, steady and predictable, spilling warmth across the oceans and mountains. And yet, beneath that reassuring constancy lies a restless heart, a furnace of plasma so vast and turbulent that even our most powerful instruments struggle to keep pace. To live on Earth is to live inside the sun's breath. Our atmosphere, our magnetic field, even our climate, all depend on the moods of this star, moods that shift in rhythms older than human civilization itself. Scientists call one of those rhythms the solar cycle. Roughly every 11 years, the sun swings from quiet calm to frenetic activity. At solar minimum, its surface appears relatively smooth, with only a few dark sunspots marring the glowing photosphere. But as the cycle advances, sunspots multiply like storm clouds. Magnetic fields twist and knot themselves into unstable loops, and suddenly, the sun begins to awaken. Solar flares erupt with the force of billions of nuclear weapons. Coronal mass ejections, great plumes of plasma hurl themselves into space, racing outward at millions of kilometers per hour. We are now living in the rising phase of solar cycle 25, and the evidence of the sun's awakening is everywhere. Sunspot counts, tracked since the early 1600s, have surged beyond what many forecasters predicted. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center issues regular alerts, watching as high-speed solar wind streams lash the Earth's magnetosphere. Auroras have been recorded farther south than at any time in over a decade, painting skies above Colorado, Illinois, even France, with luminous arcs of green and purple light. For casual sky watchers, it is a gift. For scientists, it is both thrilling and unnerving. Why does the sun behave this way? The truth is that we still do not fully know. Deep inside its core, nuclear fusion converts hydrogen into helium, releasing energy that takes thousands of years to migrate outward. By the time that energy reaches the surface, it has become light and heat, familiar, life-giving. But riding on top of this steady output is something more chaotic. The sun's magnetic personality, generated by the motion of charged particles within its convection zone. The solar magnetic field is constantly twisting, snapping, reconnecting. It is this magnetic ballet that drives the cycle, alternately calming and stirring the great star. At first glance, this should have nothing to do with life on Earth. After all, the sun is 150 million kilometers away. Its flares and eruptions seem like distant fireworks. But space is not empty. It is filled with a thin stream of particles called the solar wind, and that wind carries the sun's magnetic field outward, enveloping every planet in an invisible cocoon. When the sun is calm, the wind is steady. When the sun awakens, the wind becomes a storm, and Earth must brace itself against waves of charged particles crashing into its magnetic shield. On September 14th through 15th, 2025, one of those storms arrived. Unlike the dramatic coronal mass ejections that make headlines, this storm came from something more subtle, a coronal hole. Imagine the sun's surface not as a uniform sphere, but as a patchwork of magnetic regions. Most field lines loop back into the sun, trapping hot plasma in brilliant arches. But sometimes the lines open outward, creating highways for particles to escape. These dark patches, coronal holes, become gateways for high-speed solar wind. From coronal hole CH1316, a stream of particles raced toward Earth at more than 600 kilometers per second. When it collided with our magnetosphere, the planet shuddered under a geomagnetic storm rated G3, strong enough to disturb satellites, scramble GPS signals, and light auroras across continents. The KP index, a scale that measures geomagnetic activity from 0 to 9, soared past 6. Amateur radio operators noticed fading signals, airlines shifted routes, and ordinary people, stepping outside at midnight, found themselves bathed in emerald light, as if the sky itself were whispering secrets. For those who had been following the sun's rhythms, this was no surprise. Solar cycle 25 is peaking, and such storms are to be expected. But what caught attention was the timing. 3 days later, Kamchatka shook. The juxtaposition was irresistible. First the sun stirred, then the earth trembled. Scientists insisted that no causal link exists, that tectonic plates and solar winds are separate domains. Yet for the layperson, The sequence felt uncanny, like the echo of a drumbeat traveling from star to planet. To appreciate the sun's awakening is to appreciate scale. The numbers are staggering. A typical solar flare releases 10 circumflex, 25 joules of energy, roughly the output of every power plant on Earth, running for thousands of years. Coronal mass ejections can hurl billions of tons of plasma across space. The solar wind, though tenuous, carries enough force to sculpt Earth's magnetosphere into a teardrop shape, pressing it inward on the day side and trailing it into a vast tail on the night side. All of this happens continuously, a reminder that our world is not isolated but immersed in a sea of energy. And yet, we sleep beneath it as though nothing were amiss. That is part of the sun's paradox, overwhelming in power, subtle in presence. Its light streams through our windows each dawn, steady and reassuring, even as magnetic storms rage unseen above. It has awakened many times before, and it will again, following a rhythm that stretches far beyond human memory. But what makes this cycle different is context. The sun is awakening just as an interstellar comet approaches, just as Earth's most active fault zones are releasing extraordinary seismic energy, just as human civilization grows more dependent on fragile technologies vulnerable to electromagnetic disruption. Timing is everything, and timing is what unnerves us. Mainstream science may reject speculation, but curiosity remains. Could changes in solar activity influence not only satellites and power grids, but also the delicate balances of our planet itself? Could electromagnetic currents, generated by solar storms, seep into Earth's crust, altering stresses along fault lines already primed to slip? The United States Geological Survey says no. The data, they insist, shows no correlation. But the data is young, barely a century old, while Earth cycles stretch into the billions of years. Who can say with certainty what hidden rhythms remain unseen? For now, what we know is this: the sun is no longer slumbering. Its surface roils with sunspots. Its winds buffet our planet. Its storms paint the skies. The next few years will be a test of resilience, a reminder that even in an age of satellites and supercomputers, we remain at the mercy of forces we cannot control. So as you drift into sleep tonight, imagine the sun not as a simple ball of fire, but as a living heart. Each pulse of magnetic energy is a beat. Each flare is a breath. Each coronal hole is an artery, sending streams of charged particles racing into the dark. And here, on a small blue planet circling quietly in that storm, we feel those pulses in ways both subtle and profound. The sun has awakened, and with it, perhaps, so have we. If the sun's awakening is the sky's proclamation, then the Earth's tremors are the language of stone. Kamchatka spoke loudly in the summer and autumn of 2025, and its voice was not gentle. On July 29th, the seafloor shifted in one of the largest earthquakes recorded in modern history, a magnitude 8.8 event that rattled the Pacific Ring of Fire. Less than 2 months later, on September 18th, a second convulsion tore through the same region, registering magnitude 7.8. To seismologists, the second event was classified as an aftershock. To those who lived through it, it was another reminder that the earth beneath their feet is never truly still. The Kamchatka Peninsula is one of the most seismically active places on the planet. It sits at the edge of a vast tectonic battle. The Pacific Plate plunges beneath the Okhotsk Plate at a rate of roughly 8 centimeters per year. Imagine two massive rafts, one sliding under the other, grinding and catching until the stress builds so high that the upper raft suddenly snaps back. That release is what we feel as an earthquake. Kamchatka has experienced this dance for millennia, producing eruptions from its many volcanoes and quakes that send tsunamis racing across the Pacific. But the 2025 sequence was unusual even for Kamchatka. The July quake was so powerful, it altered Earth's rotation by a fraction of a millisecond. It triggered tsunami alerts as far away as Hawaii and Chile. It also redistributed stress along hundreds of kilometers of fault lines, effectively loading the dice for further ruptures. When the September quake struck, it was not unexpected in the statistical sense. Aftershocks of magnitude 7 or higher are a known risk after an event as colossal as 8.8. Yet the clustering, the intensity, and the timing created a sense of unease. This was not a gradual unwinding of stress. It felt like a cascade, a chain reaction echoing through the crust. Scientists use a tool called Coulomb stress modeling to understand how one earthquake influences the likelihood of another. When a fault ruptures, it doesn't just release energy, it transfers stress to neighboring regions. Some areas become more likely to slip, others less. After the July quake, dozens of nearby fault segments lit up with elevated risk. The September rupture was one of those predictions realized, but the chain did not end there. More than 40 aftershocks above magnitude 6 were recorded in just a few weeks, each one strong enough to level buildings if it had occurred on land instead of beneath the ocean. The Earth's cry, then, was not a single shout, but a chorus. Seismometers across the world traced the vibrations, delicate lines of ink spiking on paper or digital traces scrolling across screens. Each peak told a story of rocks grinding, fluids moving, energy releasing. For geologists, it was a data feast. For local residents, it was an unsettling reminder that the ground itself is alive. What makes earthquakes uniquely unsettling is their unpredictability. We can forecast storms, model hurricanes, even predict solar cycles with fair accuracy. But earthquakes defy precise timing. We know where they will happen along subduction zones, transform faults and rifts, but we cannot say exactly when. So when Kamchatka convulsed in July and then again in September, people naturally looked for patterns elsewhere. Why now? Why two giants in such quick succession? Some turned their gaze upward. Just 3 days before the September event, Earth had been struck by that G3 geomagnetic storm. While seismologists insist the connection is coincidence, the timing lingers in the imagination. Could telluric currents induced by solar storms subtly influence faults already close to failure? Could electromagnetic pulses nudge a stressed system over the edge? The mainstream answer is no. And yet, the clustering of quakes during periods of elevated space weather continues to spark curiosity. To understand why Kamchatka is so restless, we must imagine the forces at work. The Pacific Plate is massive, stretching thousands of kilometers across the ocean. As it subducts beneath Eurasia, it carries sediments, oceanic crust, and water deep into the mantle. This process generates both earthquakes and volcanic eruptions. Kamchatka's landscape is dotted with smoking volcanoes, proof of the fire below. Each quake is not just a slip of rock, but part of a grand recycling system that has shaped Earth's continents and oceans for billions of years. Without subduction, mountains would not rise, continents would not drift, and the planet would not renew itself. Still, renewal has its price. The people of Kamchatka live with the knowledge that the ground can heave without warning. Fishing villages are perched on cliffs that may someday crumble. Roads snake through valleys that can be cut off in an instant. In 1952, a magnitude 9 quake here generated a tsunami that killed thousands. In 2025, disaster was mitigated by modern warning systems, satellites, and global cooperation. Yet, the fear remains. When the Earth cries, technology can only do so much. The September quake, though smaller than July's monster, still unleashed energy equivalent to billions of tons of TNT. It rattled dishes in Alaska, swayed skyscrapers in Tokyo, and sent a whisper of vibration through seismometers in Europe. Earthquakes are reminders of our planet's unity. A rupture in one place is felt everywhere, faintly but undeniably, as if the Earth were a single living body flinching from pain. What do these cries mean? On one level, they are simply geology at work, the inevitable outcome of plate tectonics. On another, they invite metaphor. The Earth groans as though under a burden. It releases energy like a sigh. It quakes as if dreaming. In the context of 2025, with the sun stirring above and a comet approaching from the stars, these metaphors grow louder. The Earth seems to be part of a larger drama, its voice one instrument in a cosmic ensemble. As you drift towards sleep, imagine standing on a Kamchatka cliff at dusk. The sea stretches endlessly, grey and restless. Behind you, volcanoes puff thin trails of smoke. Beneath your feet, the ground is quiet for now, but you know it carries memories of violence. You look upward. The sky is streaked with aurora, faint green curtains against the stars. Somewhere beyond those stars, Atlas approaches, glowing faintly in the dark. You sense that all of these things are connected, though you cannot say how. You only know that the Earth has cried, and its echoes are not yet finished. For most of human history, comets were omens. They arrived without warning, glowing across the night like ghostly lanterns, and vanished again into the dark. Ancient civilizations recorded them on stone tablets and bamboo slips, fearing their arrival as signs of plague, war, or the fall of kings. Today, with telescopes and spacecraft, we know that comets are icy remnants from the birth of solar systems, fragments of frozen time drifting on elongated orbits. Yet even now, they still manage to surprise us. In 2025, the cosmos delivered a visitor unlike any seen before. Officially catalogued as C, divided by 2025 N1, but more evocatively called 3I, divided by Atlas. This object is not native to our solar system. The I, in its name, stands for interstellar, marking it as only the third confirmed visitor from beyond our Sun's gravitational domain. The first was Oumuamua in 2017, a cigar-shaped enigma that baffled astronomers with its strange acceleration. The second was 2I divided by Borisov in 2019, a more conventional comet, but still remarkable for its alien chemistry. Now comes Atlas, and it may be the most extraordinary of them all. Discovered by the Asteroid Terrestrial Impact Last Alert System, hence its name Atlas, appeared at first as a faint smudge of light moving against the stars. But orbital calculations quickly revealed what made it special. The path was hyperbolic, meaning it was not bound to the Sunday. This was a traveler from the gulfs between stars, an emissary from another stellar nursery, now passing briefly through our neighborhood before vanishing forever. What has stunned astronomers is how alive this visitor already seems. Most comets slumber until they are drawn close to the sun, only awakening when sunlight is intense enough to vaporize ices and release dust. Atlas, however, was active even at distances where solar heat should barely touch it. Telescopes soon confirmed the impossible. A coma, the glowing cloud of gas and dust surrounding a comet's nucleus, already stretched to 700,000 kilometers across, roughly half the diameter of the Sun itself. Imagine a tiny icy core, perhaps only a few kilometers wide, producing a cloud large enough to swallow Earth dozens of times over. This scale is difficult to grasp. From a cosmic distance, Atlas looks like a miniature star, its halo brighter and wider than entire planets. And yet, at its heart, lies nothing more than a lump of frozen rock, forged in the cold of another solar system, preserved for billions of years in interstellar exile. What alchemy allows such a small thing to produce such a vast presence? The answer lies in its chemistry. Unlike most comets, dominated by water ice, Atlas is unusually rich in carbon dioxide and exotic ices that sublimate at much lower temperatures. Even faint sunlight, millions of kilometers from the sun, is enough to awaken it. Already, astronomers are speaking of Atlas as a natural laboratory. Its coma is not just a glowing veil, but a plasma environment, interacting with the solar wind on a scale no human instrument could ever reproduce. As charged particles stream past, they strip electrons from the gas, creating ions that form vast magnetic tails. In this way, Atlas is like a net dragging through the solar wind, revealing its invisible currents and structures. To watch Atlas is to watch the sun's breath made visible. But scientific wonder is only part of the story. For those following the seismic unrest of 2025, the arrival of Atlas feels like an omen reborn. The sun has awakened, the earth has cried, and now a stranger from another star drifts into view, larger in aura than anyone could have expected. Coincidence? Perhaps. Yet the mind, searching always for meaning, cannot help but weave the three together into a single narrative. Atlas will reach its closest approach to the Sun, its perihelion, on October 30th, 2025, at a distance of about 1.4 astronomical units. That is slightly farther than Earth's orbit, closer than Mars at its farthest. Its nearest pass to Earth itself will be about 1.8 astronomical units, safely distant at 168 million kilometers. In other words, there is no danger of collision, no extinction event. But safety is not the same as insignificance. For never before have we observed an interstellar object of such size, such activity, at such a moment in our planet's story. Astronomers compare the situation to a cosmic laboratory experiment. The sun is surging into its maximum activity, sending storms across the heliosphere. Earth is restless, with aftershocks. Into this dynamic system enters Atlas, a plasma body half as wide as the Sunday. What interactions may occur? No one can predict. Some scientists speculate that Atlas might distort solar wind, flows on a scale visible across the entire inner solar system. Others see in it a chance to study interstellar chemistry up close, analyzing its coma for molecules that hint at the conditions of other stars. And then there are those who look at Atlas with a more poetic eye. To them, it is a messenger, not in the literal sense of alien intelligence, but as a symbol, a reminder that our solar system is not isolated, that the universe is a web of journeys and encounters. Once in a while, a traveler slips between the stars and brushes past our world, reminding us of distances we cannot yet cross, of stories we have not yet heard. If you step outside tonight and look upward, you will not see Atlas with your naked eye. Not yet. But telescopes already show its vast halo, glowing like a ghost in the darkness. Astronomers trade images across the internet, each one a little clearer, a little stranger, as if they are collectively unwrapping a gift from the cosmos. The excitement in their voices is unmistakable. This is not just another comet. This is something new, something that expands the boundaries of imagination. As you listen, imagine yourself floating in the silence of space, drifting toward Atlas. At first it seems like a star, a glowing orb. But as you approach, you realize it is not solid but vaporous, a sphere of dust and gas so diffuse you could pass through it like mist. Somewhere at the center, a nucleus spins dark, icy, small, compared to the vastness around it. Yet from this tiny seed emanates a presence that rivals worlds. You glide through its coma, particles brushing your skin like whispers. You are inside the breath of a comet, and for a moment you understand how fragile, how magical, this universe truly island. Atlas has no intention, no will, no message. It is simply following its path, shaped by gravity and the momentum of its ejection from a distant star system. But to us, its timing feels uncanny. As the Earth trembles, as the Sun awakens, Atlas appears. We do not need to assign it meaning for it to be meaningful. Its very existence expands our sense of the possible. It whispers of other suns, other worlds, other stories drifting through the dark, waiting to be found. This is the cosmic stranger, and it has entered our story. Picture a stage vast beyond comprehension. At its center, a star blazes, a furnace of plasma so immense that over 1,000,000 Earths could fit inside. Around it, a small blue planet circles at just the right distance, cradling oceans, forests, cities, and fragile lives. Beyond them, in the darkness, an interstellar visitor approaches a glowing wanderer carrying the chemistry of alien suns. Each has its own story, its own rhythms, its own reasons for existing. Yet in the autumn of 2025, their stories intersect. Earth trembles, the Sun awakens, Atlas enters. Three separate forces converging into one cosmic drama. Let us pause and consider each actor. The Earth is ancient, 4.5 billion years of shifting plates and roaring volcanoes, of continents colliding and splitting apart. Its crust creaks like the beams of an old house, stressed by the endless motion of tectonic plates. Earthquakes are its voice, sudden and violent, reminders that stability is an illusion. The Sun is older still, 5 billion years into a 10 billion year lifespan. A magnetic giant, its moods ripple outward in storms of charged particles. Invisible rivers that can disrupt satellites, paint the sky with aurora, and perhaps, though this remains speculation, whisper to the stressed rocks below. And then there is Atlas, a younger story for us, but ancient in its own right. Forged in another star system, wandering for eons through the interstellar void, it has arrived by chance, its massive coma billowing like a lantern. To see them together is to realize that no part of the cosmos exists in isolation. Earth's seismic unrest, the Sun's magnetic fury, the comet's radiant coma, they may seem unconnected, yet they share the same stage. Our planet orbits within the Sun's vast atmosphere, the heliosphere, a bubble of plasma that stretches billions of kilometers outward. Atlas now enters that bubble, its ionized gases colliding with the same solar wind that shapes Earth's auroras. We are all swimming in the same sea of particles, bound by forces we only partly understand. The triad of forces raises a profound question. Are these simply coincidences, or is there a hidden symphony beneath the noise? Science leans toward coincidence. The Earth's quakes are the outcome of tectonic processes millions of years in the making. The Sun's storms follow the natural rhythm of its magnetic cycle. Atlas is on a trajectory, determined long ago, ejected from another star's nursery. Each event, on its own, is comprehensible. But when they occur together, overlapping in time, the human mind strains to weave them into a single pattern. We are pattern seekers. The same instinct that helped our ancestors survive spotting tracks in the dirt, watching for changes in the sky, drives us to connect dots even when no line exists. Still, what if sometimes the patterns are real? What if Earth, Sun, and comet are not isolated notes, but chords, resonating together in ways we have yet to measure? Consider this. The Sun's magnetic storms generate telluric currents, electrical flows that course through the Earth's crust. These currents, in turn, follow conductive pathways along faults and fractures. Most of the time, they are too weak to matter. But if a fault is already loaded with stress, balanced on the edge of rupture, could a subtle current be the nudge that tips it over? Science does not yet have the answer. Atlas adds another dimension. Its coma, spanning half the Sun's diameter, is not just a cloud of dust, but an active plasma environment. As the solar wind streams past, the comet interacts with it, creating bow shocks, turbulence, and electromagnetic ripples. These disturbances ripple outward, joining the vast current sheet that threads the solar system. Earth orbits within that current sheet, like a violin string stretched across a vibrating soundboard. Might the arrival of such a massive plasma veil alter the symphony of currents flowing through the heliosphere? Again, speculation, but speculation worth entertaining as we drift into the mysteries of sleep. Think of the triad not as three separate events, but as three dancers moving in overlapping patterns. The Earth sways with seismic shudders. The Sun spins with magnetic flares. The comet drifts gracefully through their field of influence. At times, the steps align, and the dance takes on new meaning. At other times, they drift apart, each lost in its own rhythm. To witness them together is to glimpse the choreography of the universe. For those living on Earth, the stakes feel personal. A geomagnetic storm can disrupt power grids and communications, reminding us of our technological fragility. An earthquake can level cities, reminding us of our physical vulnerability. A comet's approach can stir fears of collision, even when astronomers assure us it poses no threat. Each force touches us in a different way, and together they remind us that our existence depends on forces beyond our control. And yet, there is beauty in this lack of control. To lie beneath a sky glowing with auroras, to feel the tremor of the ground beneath your feet, to know that an object from another star system is passing overhead, these are experiences that place us firmly in the story of the cosmos. They remind us that we are not outside observers, but participants, woven into the same fabric as stars and comets. In moments like these, humanity has often turned to myth. Ancient cultures might have seen the triad as gods in conversation, the earth deity groaning, the sun deity roaring, the stranger god arriving with messages from afar. In our scientific age, we replace gods with data, but the longing for meaning remains. We ask not only how, but why. Why now? Why these events together? What does it mean to live in a universe where such convergences occur? As you drift deeper into rest, let your mind hold the image of this cosmic triangle. At one corner, the trembling earth, restless and ancient. At another, the awakening sun, fierce and radiant. At the third, Atlas, the glowing stranger. Between them stretches an invisible web of forces, magnetic fields, gravitational pulls, streams of plasma that bind them together in ways we are only beginning to imagine. Whether or not they are truly connected, the thought itself is enough to expand our sense of belonging in the universe. Tomorrow, seismologists will publish reports, solar physicists will issue forecasts, astronomers will track Atlas's coma. They will each speak their own language, careful, precise, cautious. But tonight, in the quiet of your imagination, you are free to let the boundaries dissolve. Earth, sun, comet, three instruments, one symphony. The triad of forces is playing now, and we are listening from within the orchestra itself. For centuries, earthquakes and storms seemed to belong to different realms. One was the language of stone, the other the language of air and sky. When the ground shook, people looked downward, blaming restless mountains or angry gods beneath the earth. When the heavens glowed with auroras or lightning split the night, they looked upward. Rarely did anyone think to connect the two. And yet, as science has deepened our understanding of Earth and space, a curious possibility has begun to emerge. Perhaps the boundaries we draw are thinner than we imagine. Space weather is the term scientists use to describe the influence of the sun on Earth's environment. It is not weather in the traditional sense. There are no clouds or rain showers drifting across the vacuum of space. Instead, space weather refers to the solar wind magnetic fields, and bursts of energy that stream outward from our star and wash over our planet. Most of the time, Earth's magnetic field shields us from harm. But when the sun awakens, when coronal holes open or flares erupt, the flow intensifies, and the effects can be profound. Satellites falter. Power grids hum with unwanted currents. Auroras blaze across unexpected latitudes. Earthquakes, on the other hand, are born deep within the crust. They are driven by tectonic plates grinding against each other, by stresses accumulated over centuries, suddenly released in seconds. The mechanics are well understood. Faults slip, waves ripple outward, buildings sway, lives are changed. On the surface, earthquakes and space weather could not seem more different. One is mechanical, the other electromagnetic. One arises from solid rock, the other from streams of plasma. And yet, some researchers have asked, could there be a hidden bridge between them? Could the sun's mood somehow influence the Earth's crust? Not by adding vast amounts of energy, an earthquake releases more than 100 nuclear bombs worth of force, but by nudging a system already on the edge. In other words, could space weather act as a trigger for earthquakes that were going to happen anyway? The mainstream scientific answer is cautious, bordering on skeptical. The United States Geological Survey, the world's leading authority on seismic activity, states clearly that there is no proven causal link between solar storms and earthquakes. Statistical studies have repeatedly failed to show consistent correlations across large datasets. Earthquakes occur daily, somewhere on Earth, while solar storms are frequent during the solar maximum. Coincidences are inevitable. Most experts argue that when you look carefully, the numbers simply do not align. But science also thrives on outliers, on anomalies that refuse to fit. And here, the timing of certain events keeps drawing attention. The September 18th, 2025 quake in Kamchatka came just 3 days after a strong geomagnetic storm. In July 2011, Japan's Tohoku region experienced aftershocks during a period of heightened solar activity. In 2004, the catastrophic Sumatra earthquake occurred in the midst of unusual space weather. Coincidence? Very likely. Yet the human mind, ever alert to patterns, cannot let go so easily. Alternative researchers have put forward several mechanisms by which space weather could, in theory, influence seismic events. One involves telluric currents, electric currents, induced in Earth's crust by geomagnetic fluctuations. During strong geomagnetic storms, these currents can reach surprising intensities, following the paths of underground water, mineral veins, and fault lines. If a fault is already critically stressed, could a sudden surge of current alter fluid pressure in microscopic cracks, changing the delicate balance enough to trigger a slip? Another proposed mechanism points to changes in atmospheric pressure. Solar storms disturb the ionosphere, heating it and altering its density. Some theorists suggest that these changes might ripple downward, affecting weather patterns and even subtle pressures on the crust. A third idea, more speculative still, imagines that electromagnetic waves generated during storms could penetrate the crust directly, influencing rock mechanics at a molecular level. Mainstream science remains doubtful. The energy involved in space weather, while vast on a planetary scale, is minuscule compared to the forces locked within Earth's plates. A magnitude 7 earthquake releases around 10 circumflex 15 joules of energy, while the electrical energy delivered to the crust by a geomagnetic storm is orders of magnitude smaller. It seems implausible that such a small nudge could unleash such a colossal event. And yet, history shows that earthquakes can be remarkably sensitive to small triggers. Ocean tides, caused by the moon's gentle pull, have been statistically linked to increased seismicity along certain faults. If the rhythm of the ocean can sway the Earth, why not the rhythm of the sun? The debate continues, fueled by both data and imagination. On one side stand the rigorous statisticians, reminding us that correlation is not causation, that our minds are prone to finding patterns in noise. On the other stand the explorers of possibility, pointing to clusters of events that feel too uncanny to ignore. The truth may lie somewhere in between. Perhaps most earthquakes are entirely unaffected by space weather. But perhaps a small subset, in regions already on the brink, could be tipped by the invisible breath of the Sunday. For those who live in seismically active zones, the speculation offers little comfort. Whether triggered by tectonics alone or nudged by space storms, the ground still shakes, and lives are still disrupted. But for those who gaze at the broader picture, the possibility is tantalizing. It hints at a universe more interconnected than we assume, where sky and stone, plasma and granite are woven into the same fabric. As you drift into rest, imagine Earth's crust as a vast web of springs, stretched tight by the slow grinding of plates. Now imagine the sun as a drummer, its magnetic storms beating invisible rhythms across the solar system. Most of the time, the web holds. But once in a while, a beat aligns with a point of weakness, and the web snaps. Whether that snap was inevitable or influenced is a question still open. Mainstream or fringe, caution or curiosity, the question itself reminds us of our place in the cosmos. We are not separate from the sun's moods. We are not immune to its storms. We are part of a living system, a planetary body orbiting within a star's breath. To explore the possible connections between space, weather, and earthquakes is not to abandon science, but to expand it, to consider that even in geology's hardest stones, the whispers of the stars may sometimes be heard. And so, in 2025, as Kamchatka quakes and auroras shimmer, we stand at the edge of knowledge, listening to both scientists and dreamers. The verdict is not yet in. But the question, could the sun's storms influence Earth's tremors, is enough to keep us awake, or to lull us into the deepest kind of wonder as we close our eyes. The sun's breath is not steady. Though we call it the solar wind, it is less like a gentle breeze and more like a shifting tide, sometimes calm, sometimes furious, and sometimes strangest of all, nearly absent. To understand the rhythms of this invisible stream is to glimpse one of the most intriguing and controversial ideas in space science, the so-called vacuum hypothesis. Imagine the sun's magnetic field as a vast tapestry, its threads twisting and tangling before snapping open. Most of the time, the plasma trapped in these magnetic loops simply boils and churns above the surface, creating familiar sunspots and arcs of fire. But in certain places, the loops open outward into space. These regions, called coronal holes, act like gateways, releasing high-speed streams of charged particles. When these streams reach Earth, they produce geomagnetic storms, shaking our magnetosphere and lighting up the polar skies with auroras. Yet the vacuum hypothesis suggests something deeper. Observations show that during these high-speed streams, the density of solar wind particles can drop dramatically. Imagine standing by the ocean as waves roll toward you suddenly. Instead of more water, there is less. A kind of void, a thinning. In space, this thinning creates what researchers call a solar wind vacuum. Particle counts plummet to less than 1 proton per cubic centimeter, emptier than any laboratory vacuum we can create on Earth. It is in these rare vacuums that some believe the seeds of earthquakes may be sown. The idea is not that the sun somehow pours energy into the Earth's crust, an impossibility given the scale of forces involved, but rather that the sudden change in pressure on Earth's magnetic shield alters the delicate balance of currents flowing through our planet. Earth's magnetosphere is a bubble inflated by solar wind. When the pressure drops, the bubble expands. reshaping the pathways of electric currents that flow through both the atmosphere and the crust. These currents, called telluric currents, are well documented. Power companies monitor them because they can overload transformers and corrode pipelines. They flow naturally through conductive rock, groundwater, and mineral veins. In ordinary times, they are background whispers, harmless. But during geomagnetic storms, they can surge dramatically. The vacuum hypothesis suggests that when the magnetosphere suddenly expands due to a thinning of the solar wind, these currents shift in ways that could subtly affect stresses along tectonic faults. Imagine a fault line deep beneath the ocean, already loaded with centuries of accumulated strain. Rocks press against each other with immense force, their friction the only thing holding them in place. It is as though two wrestlers lock hands, each refusing to yield. Then, without warning, an external nudge tips the balance. Not a shove, but a whisper just enough to break the stalemate. In this metaphor, the whisper is the electromagnetic change brought by the solar wind vacuum. Skeptics point out that the energy differences involved are vanishingly small compared to tectonic forces. How can a change in solar wind density, measured in a handful of protons, possibly influence masses of rock kilometers deep? The answer, if it exists, may lie not in absolute energy, but in timing. Earthquakes, like avalanches, are systems balanced on the edge of instability. The tiniest shift can determine whether the snowpack holds or slides, whether the fault remains locked or slips. Some studies have claimed statistical correlations between major earthquakes and periods of unusually low solar wind density. Researchers comb through decades of seismic catalogues, comparing them with records of space weather. The patterns are far from conclusive, but they are intriguing. In 2004, before the catastrophic Sumatra quake, solar wind density dropped sharply. In 2011, before the Tohoku disaster in Japan, a similar thinning was recorded. In 2025, before Kamchatka's September rupture, the same pattern appeared again: a coronal hole stream, a sudden vacuum, a quake days later. Coincidence? Probably, many scientists say. Earthquakes occur so frequently that correlations are bound to appear if you look hard enough. But the persistence of the pattern tempts the imagination. Could the Earth's crust really be that sensitive to the sun's rhythms? To explore the hypothesis further, picture Earth not as a solid rock, but as a layered, electrically conductive sphere. Its core spins, generating a magnetic field. Its mantle flows slowly, carrying heat upward. Its crust cracks, storing strain. All of it is bathed in electromagnetic currents. From the Sunday, during a vacuum event, when the solar wind thins, the pressure on this system changes. The magnetosphere expands outward, like a balloon suddenly given more air. Currents within it reconfigure, inducing new patterns in the crust. The effect might be subtle, but for a fault poised on the edge of failure, subtle may be enough. Mainstream seismology resists the idea. Rightly so. Extraordinary claims demand extraordinary evidence, and so far, the vacuum hypothesis has not cleared that bar. No controlled experiment can replicate Earth's tectonic system. No laboratory can model the combined dance of solar wind, magnetosphere, and seismic stress at planetary scales. All we have are correlations and imagination. Yet science often begins this way, with a pattern that refuses to fade. What fascinates those who entertain the hypothesis is its elegance. It does not require mysterious new physics or alien intervention. It simply proposes that Earth, immersed in the sun's breath, responds not only to the surges, but also to the absences, the voids, the lulls, the silences. Just as the absence of sound can be as powerful as a shout, the absence of particles in the solar wind may matter as much as their presence. As you listen now, consider how sensitive we are to absence. A pause in conversation can change its meaning. A gap in a melody can heighten emotion. A moment of silence can feel louder than noise. Perhaps the Earth, too, responds to such silences in the solar wind, its crust shifting when the cosmic music briefly drops away. Whether true or not, the vacuum hypothesis invites us to see Earth as part of a larger system, connected in ways we do not yet fully understand. It suggests that our planet is not just a passive stage for cosmic events, but an active participant in the solar symphony. The sun plays its rhythms, the Earth responds, and sometimes, in the pauses, the crust itself trembles. So as you close your eyes tonight, imagine drifting outward into space, past the blue glow of Earth, into the stream of solar wind. Feel the particles rushing by, billions per second. Then, suddenly, the stream thins. Silence, emptiness. A vacuum so pure it makes your lungs ache with longing. In that silence, far below, a fault line cracks, releasing its own thunder. Two silences, one in space, one in stone, meeting in a single moment. Coincidence, perhaps, or maybe, just maybe, the whisper of the sun is enough to make the Earth cry out. The story of Kamchatka in 2025 is not a single quake, but a chorus of them, a sequence so insistent it felt like the peninsula itself had become a drum. From July through September, the ground shook again and again, each tremor arriving like a verse in a longer song. To scientists, these were aftershocks. To those who lived there, they were reminders that the Earth was restless, unwilling to return to silence. The tale begins on July 29th, when the seafloor ripped open with a magnitude 8.8 quake. This was no ordinary rupture. It was a megathrust, the kind of event that rearranges coastlines and enters history books. In less than 3 minutes, hundreds of kilometers of fault slipped, releasing energy equivalent to billions of tons of TNT. The quake shortened Earth's day by fractions of a millisecond, a reminder that these events are not only local but planetary. When such a quake strikes, the Earth rarely returns to calm quickly. Stress redistributes along the fault, pressing on nearby segments like dominoes nudging each other. Aftershocks ripple outward, each one smaller than the main event but powerful enough to terrify. In Kamchatka, the aftershock sequence was unusually fierce. More than 40 quakes above magnitude 6 struck in the weeks that followed. Entire villages lived in a state of half-sleep, startled awake at night by walls creaking, dogs howling, and the ground shifting beneath them. Among these aftershocks came the September 18th quake, magnitude 7.8. By definition, it was smaller than the July monster. Yet in any other context it would have been headline news, a disaster in its own right. Scientists explained it as a natural consequence of stress transfer, the crust seeking balance after its massive rupture. But for those who had already endured weeks of trembling, it felt like the Earth had broken its promise of recovery. The land kept moving, as though it could not forget the violence it had unleashed. Picture a fisherman in a coastal village. He survived July, repaired his nets, and returned to sea. Each time he drops anchor, he listens not only to the waves, but to the silence beneath them, wondering if it will hold. In August, a smaller quake rattles his cabin. In September, the 7.8 quake knocks jars from his shelves. He stares at the horizon and feels a strange truth. Home is not solid, not certain, but a raft riding restless forces. Scientists studying the Kamchatka cluster see it as a laboratory of tectonics. The peninsula sits at a subduction zone, where the Pacific plate dives beneath the Okhotsk plate at roughly 8 centimeters per year. Over decades, this motion locks portions of the boundary, building strain. The July quake was the release, but release is never simple. Some sections of the fault slipped fully, others only partially, leaving patches of strain that the September quake exploited. The sequence is like a symphony, a crashing overture followed by echoing movements, each one carrying fragments of the theme. Yet there is another layer. The cluster coincided with extraordinary space weather. On September 15th, a geomagnetic storm rattled Earth's magnetic shield, spreading auroras far south of their usual haunts. 3 days later, Kamchatka shook. For mainstream geophysics, the connection is coincidence. For storytellers, it is rhythm. The storm above, the quake below, both part of the same September cadence. The Kamchatka cluster also drew attention for its sheer relentlessness. People described the land as alive, a body that would not stop twitching. The psychological toll was immense. Sleep deprivation set in. Every thump of a truck or slam of a door felt like another quake beginning. Children clung to parents. Adults carried emergency bags at all times, and neighbors checked on one another with new tenderness. Catastrophe, in its repetition, had reshaped community. Historically, Kamchatka has produced such clusters before. The peninsula is one of the most seismically active regions on Earth, a hotbed of volcanoes and quakes. Indigenous folklore speaks of spirits beneath the land, restless and fiery, their moods expressed in shaking ground and steaming vents. Modern instruments replace spirits with data, but the impression is the same. Kamchatka is never still. It breathes in fire, exhales in tremors, and reminds humanity that we live on moving ground. What makes the 2025 cluster so striking is its timing within a broader context. Humanity was watching the skies for 3. Eye divided by Atlas, marveling at its vast veil. Humanity was also tracking solar storms, noting their intensity. And then, beneath our feet, the Earth added its own verse. To some, it felt as if the universe had coordinated a performance comet above, Aurora in the middle, quake below. The Kamchatka cluster was not merely geological, it was symbolic, a reminder of Earth's role in the cosmic symphony. Imagine standing on a dark beach in September. To the north, faint auroras ripple like green silk. To the east, the ocean glints under starlight. Beneath your feet, the ground murmurs with aftershocks, subtle but undeniable, and far overhead, a comet drifts, its coma larger than the sun itself. You are a single human, in a vast alignment, caught between trembling earth and breathing sky. Whether coincidence or chorus, the Kamchatka cluster asks us to reconsider stability. We often assume the ground is firm and the heavens distant. But in moments like these, both feel close, both feel alive, both demand humility. The ground beneath can move without warning, and the sky above can shimmer with storms from a star 150 million kilometers away. Together, they remind us that security is an illusion and awe is the truest response. So tonight, as you lie down, picture the cluster not as chaos but as music. Each quake is a drumbeat, each aurora a violin note, each comet a distant horn. The orchestra is vast, the score unfinished, but the performance is real. You are both audience and participant, carried by rhythms older than civilization. The Kamchatka cluster may be explained by physics, but it is also felt as poetry, and in the quiet between tremors, you can still hear the Earth's heartbeat. When the sun stirs, the Earth listens. We cannot see the particles rushing through space, but their arrival leaves traces everywhere on our skies, our machines, even on our imagination. The September 2025 storm was one of those moments when the invisible became visible, when solar wind collided with Earth's magnetic shield and painted the heavens in living color. To the untrained eye, it was beauty. To scientists, it was a storm. To both, it was unforgettable. The story began days earlier, when a coronal hole opened wide on the sun's surface. Through that gap, streams of plasma, mostly electrons and protons, escaped at astonishing speeds. Instruments aboard NASA's ACE and DS cover spacecraft detected the approaching gust. Solar wind rushing toward Earth at nearly 700 kilometers per second. Density dropped, velocity climbed, and the interplanetary magnetic field tilted southward, the orientation most likely to stir Earth's defenses. On September 15th, the storm arrived. The KP index, a measure of geomagnetic disturbance, leapt to 7, classed as a G3 storm, strong, but not catastrophic. Yet classifications are abstractions. What people experienced was not a number, but a spectacle. Curtains of green light unfurled above latitudes unaccustomed to such sights. In the American Midwest, families stepped onto porches in astonishment. In Germany, photographers rushed to fields, capturing arcs of violet, crimson, and jade across the sky. In Japan, children pointed to the horizon, where faint glows wavered like distant fires. For those who had never seen an aurora, it felt otherworldly. Light moved as though alive, shimmering, twisting, shifting in real time. Unlike the steady glow of stars, auroras ripple like silk caught in a breeze, their shapes sculpted by invisible magnetic forces. To watch one is to witness the sky, remembering it is not passive, but responsive, a canvas reacting to the breath of the Sunday. But beauty carried weight. Satellites in orbit registered surges of current, forcing adjustments to protect delicate instruments. GPS signals wavered, introducing errors into navigation systems. Airline companies rerouted polar flights, worried about increased radiation at high latitudes. On the ground, long-distance power lines in Canada and Scandinavia hummed with induced currents, a faint but measurable reminder that the Earth itself is wired into the storm. At NOAA's Space Weather Prediction Center, scientists tracked every fluctuation. Their screens displayed graphs of solar wind speed, density, and magnetic field orientation. Each curve was like a heartbeat, each spike a shout from the Sunday analysts issued alerts, not of catastrophe, but of caution. They spoke of possible power disruptions, communication hiccups, and auroras visible far beyond their usual haunts. To the public, it was a rare opportunity to witness beauty. To operators of satellites and grids, it was a night of vigilance. What fascinates those who reflect on this storm is not only its impact, but its timing. 3 days later, Kamchatka shook with a magnitude 7.8 quake. Officially, the two events are unrelated, one the work of the sun, the other of the Earth's plates. But in the cadence of September, they sounded like call and response, a storm in the sky, a quake in the ground, a rhythm, even if imagined. Consider how ancient peoples would have read this alignment. In China, auroras were celestial banners, omens of change. In Norse tradition, they were Valkyries riding across the heavens, their light signaling battles below. To Polynesian navigators, shimmering skies were messages from gods guiding their journeys. If those same witnesses had seen Kamchatka quake days later, they would not have hesitated to connect the dots: sky and ground, cause and consequence. Our modern skepticism shields us from such leaps, but the instinct remains. The geomagnetic storm also invited reflection on scale. We think of Earth as large, yet our entire planet fits comfortably within the sun's magnetic breath. Each day, solar wind shapes our magnetosphere like an artist molding clay, stretching and compressing, tugging and teasing. During storms, the pressure mounts, and Earth's magnetic shield groans under the strain. Auroras are the visible size of that struggle. They are not decorations, but evidence of a contest between star and planet. Imagine Earth as a drum. The solar wind is the drummer, tapping rhythms across its magnetic skin. Most taps are soft, unnoticed. But sometimes, the drummer strikes harder, and the drumhead vibrates in colors and currents. The September storm was such a strike, loud enough for humanity to hear, see, and feel. For scientists, the storm was data. Instruments recorded the precise tilt of the magnetic field, the strength of solar wind, the timing of auroral expansion. Papers will be written, graphs plotted, theories tested. But for those who looked up that night, the storm was poetry. It was the sky come alive, a reminder that space is not empty but charged with energy. And perhaps that is the real significance. Events like these remind us that we live not on a quiet, isolated rock, but inside a system alive with breath and motion. The sun is not a static lamp in the sky. It is a star with moods, capable of storms that reach across millions of kilometers to stir our world. To ignore that reality is to miss the intimacy of our connection. As you lie down tonight, imagine the storm once more. Picture green rivers of light streaming overhead, violet flames flickering at their edges. Imagine satellites adjusting their paths, pilots steering planes south, engineers monitoring power grids. Imagine Kamchatka, waiting unknowingly for its own upheaval days later. And imagine yourself, small but connected, breathing under a sky that trembles with the breath of a star. The September 2025 storm was not the largest ever recorded. It did not collapse grids or blind satellites, but it was enough to remind us, Earth listens to the sun, even when the sun whispers in storms. And sometimes, when sky and ground move close in time, it feels as though they are speaking to each other, one in light, the other in stone. Imagine for a moment that our planet is not simply a ball of rock, water, and air, but an electrical circuit alive, dynamic, responsive to cosmic currents. It is a daring thought, yet one that scientists and philosophers alike have entertained for centuries. Lightning, auroras, and the shimmering currents of the ionosphere are reminders that electricity is not confined to wires and batteries. It is woven into the fabric of the Earth itself. Every second, vast flows of energy pass between the ground, the atmosphere, and space. This invisible network is known as the global electric circuit. Think of it as a planetary heartbeat. Thunderstorms act like giant batteries, charging the upper atmosphere while rain, soil, and oceans close the loop. High above, the ionosphere, a shell of charged particles that envelopes Earth, acts like a glowing conductor, linking everything together. It is here, in this shimmering layer, that space and Earth meet. When the sun is calm, the circuit hums along quietly. But during storms, when solar wind rushes toward Earth, the circuit sparks and flares. The magnetosphere, the magnetic shield that cocoons our planet, is compressed and stretched like a rubber band. Charged particles funnel down along magnetic field lines, striking the upper atmosphere and creating auroras. But they also drive electric currents into the ground. These are geomagnetically induced currents, or GICs, and they flow silently through pipelines, power lines, and even the bedrock beneath our feet. Engineers know this well. In 1989, a solar storm knocked out Quebec's entire power grid in less than 2 minutes. Transformers overheated, relays tripped, and millions sat in sudden darkness. That storm was not unique. It was simply powerful enough to remind humanity that Earth's circuit can be overloaded. But here's where the story becomes more intriguing. Some researchers suggest that these currents do not only affect machines, they might also whisper to the Earth's crust itself. Fault lines, those great seams where tectonic plates grind and jostle, are electrically conductive in surprising ways. Water, minerals, and metallic ores can create channels where electricity flows more easily than through surrounding rock. When GICs arrive, they follow these paths of least resistance. Could they, in theory, nudge an already stressed fault toward slipping? Mainstream seismology resists this idea. Earthquakes, the discipline insists, are the work of mechanical stress, not cosmic weather. And yet, when one looks at the timing of certain quakes, like Kamchatka's September 18th tremor, so soon after a geomagnetic storm, the question lingers. Coincidence? Or a sign that the Earth's circuit responds to cosmic surges? To grasp the scale, imagine the Earth as a giant dynamo. The outer core, composed of molten iron, churns constantly, generating the magnetic field that protects us. Above it, the crust carries fractures filled with salty water and metallic veins. This structure is not inert, it is a conductor. When magnetic fields change outside, currents ripple within. The planet is not sealed off. It resonates like an instrument. The concept is not entirely foreign to science. Tiny tidal forces from the moon, far weaker than tectonic stresses, can sometimes trigger quakes already poised to break. Similarly, atmospheric pressure changes and seasonal rainfall have been linked to subtle shifts in seismicity. If such small influences matter, why not electromagnetic nudges? The debate remains open, but the metaphor of Earth as a circuit is compelling. Now, imagine yourself walking at night, beneath a sky alive with auroras. Beneath your feet, fault lines hold tensions accumulated over centuries. Above your head, charged particles race down magnetic field lines, stirring currents in the ground. You are sandwiched between forces vast and unseen, a living witness to the Earth's place in a cosmic web. The Earth as a circuit is not just a scientific model. It is also a metaphor for connection. Every thunderstorm, every lightning strike, every solar storm is a reminder that no part of our planet is isolated. A storm in the Amazon rainforest feeds the same circuit as a storm in Siberia. The flicker of auroras in Alaska responds to currents triggered by plasma escaping the sunday. The quake in Kamchatka, though born of tectonic stress, occurred in the same days that this global circuit pulsed hardest. It is tempting to imagine the Earth as a node in an even larger network, a participant in a galactic circuit that extends across light years. Plasma physicists describe the universe itself as an electrical tapestry with filaments of charged particles connecting galaxies like strands of a cosmic web. If that view is correct, then Earth's circuit is not unique, but part of a grander design. Our storms, quakes, and auroras are but local notes in a universal symphony. For now, science stops short of such sweeping claims. But even within the bounds of accepted knowledge, the Earth as a circuit changes how we think about our place. It reminds us that we are not separate from the sun, not immune to its moods. Our atmosphere glows when struck, our machines falter, and perhaps even our ground shifts in sympathy. The boundary between space weather and Earth weather blurs until the two seem almost indistinguishable. As you lie back, consider this invisible web. Picture thunderclouds charging the sky, lightning bolts sparking the connection, auroras rippling like neon rivers, and deep underground, quiet currents threading through stone. Imagine the Earth as a vast battery, alive with power borrowed from the sun, returned in flashes, storms, and quakes. The Earth is not silent. It hums, and if you listen closely, you may hear not only the rumble of tectonic plates, but the electric whisper of a planet forever wired into the cosmos. Imagine standing on a dark hillside, your breath fogging in the night air, when suddenly the sky blooms with multiple tails of light. Not one comet, not two, but a swarm, a gathering of celestial wanderers all arriving in the same season, as though the universe decided to stage a performance just for those patient enough to look up. This is not fantasy. It is the reality of late 2025, a time when astronomers and dreamers alike we'll witness a phenomenon without equal in living memory. A cosmic ballet of 7 comets, sweeping through the inner solar system almost simultaneously. For much of history, comets were seen as omens, fiery messengers of disaster or change. Ancient records from China, Babylon, and Europe describe them as hairy stars, unpredictable intruders into the orderly heavens. To kings and farmers, they heralded plagues, wars, or the death of rulers. Yet modern science has transformed them from harbingers of doom into bearers of knowledge. They are frozen archives, carrying within them the chemistry of creation itself. When several arrive together, the opportunities for discovery multiply. But so do the questions about why. At the head of the 2025 swarm is 3I divided by Atlas, the interstellar visitor whose vast carbon dioxide-rich coma has already astonished astronomers. Its sphere of activity, hundreds of thousands of kilometers wide, dwarfs anything seen from comets born within our solar system. Behind it trail familiar but no less intriguing companions. Comet Swan, C divided by 2025 R2, developing a dazzling tail already visible to binoculars. C divided by 2025 A6 Lemon, brightening far faster than models predicted. And several periodic travelers like 210P divided by Christensen and 24P divided by Shaumas, returning visitors whose behavior can be compared with their past apparitions. Together, they form an ensemble, a chorus of icy wanderers converging at the very moment when the sun itself is at its most active in over a decade. To an astronomer, this is like finding a library of ancient scrolls opened all at once. Each comet tells a different story. Swan's dust tail, graceful and curved, reveals how sunlight nudges particles of different sizes along slightly different paths, like feathers drifting in a breeze. Lemon's ion tail, straight and electric blue, whispers of plasma, magnetic fields, and charged particles racing at unimaginable speeds. Atlas, with its massive coma, is more than just an icy traveler. It is a probe of interstellar chemistry, a messenger from another Sunday. But to a dreamer, the sight of a sky crowded with comets feels almost theatrical. Imagine the ancients watching such a display. Would they not see it as a council of gods convening above the earth? Would they not whisper that the heavens themselves were conspiring to send a message? Even today, with satellites and spectroscopes, the sight will stir something primal in us: awe, reverence, and a touch of unease. What makes this convergence extraordinary is timing. Comets follow their own orbits, most taking thousands or even millions of years to swing back near the Sunday. That several should arrive in the inner solar system during the same season, while the sun itself surges toward maximum activity, is rare beyond measure. Scientists call it coincidence, the result of orbital mechanics and observational discovery clustering together. Yet one can't help but wonder if larger patterns are at play. Are we witnessing a natural cycle of comet influx, perhaps triggered by subtle gravitational nudges from the giant planets? Or is it simply that our instruments are now sensitive enough to detect visitors that once would have slipped by unnoticed? The scientific harvest from this swarm will be immense. The James Webb Space Telescope is poised to capture spectra of cometary ices, revealing fingerprints of molecules forged in distant star nurseries. The Hubble Space Telescope continues to map coma structures with unmatched resolution. On the ground, observatories from Hawaii to Chile track brightness changes night by night, like doctors monitoring vital signs. Amateur astronomers, too, will play a role, their photographs adding to the global mosaic of observation. For the first time, humanity will study a group of comets under the same solar conditions, a comparative experiment offered freely by the cosmos. Yet the swarm also invites more mystical interpretations. Some see in it a metaphor for humanity itself. Countless individuals, each carrying a unique history, converging in a single epoch of transformation. Just as comets bring with them ancient ices and dust, so do we carry memories, traumas, and dreams. When they pass the sun, comets are transformed dark, frozen bodies, igniting into radiant splendor. Perhaps the swarm reminds us that under the right conditions, even what is cold and forgotten can burst into light. Consider the sheer beauty of it. Swan's tail stretching 5 times the width of the full moon. Lemon, once dim, suddenly visible to the naked eye. Atlas. Invisible behind the sun but detectable in radio and X-ray emissions. And Christensen, a humble periodic traveler, offering a baseline against which the newcomers are measured. 7 wanderers, each a variation on the theme of ice, dust, and sunlight, performing together in a sky already alive with auroras from geomagnetic storms. From a scientific perspective, the comets act like natural spacecraft. Their comas and tails interact with the solar wind, tracing invisible magnetic fields, mapping plasma densities, and even responding to solar eruptions in ways our satellites cannot. When a coronal mass ejection slams into a comet, the impact can sever its ion tail completely, a cosmic amputation captured on film. When solar wind speeds surge, the shapes of comas shift, recording changes in the heliosphere. In this sense, the comet swarm is not only beautiful but useful, offering a distributed array of probes scattered across millions of kilometers. And then there is the simple, human dimension. For most of us, the swarm will be experienced not through data, but through wonder. Families will gather in backyards, craning their necks. Photographers will trek into deserts and mountains, chasing dark skies. Some will write poetry, some will whisper prayers, some will simply fall silent before the spectacle. The sky will remind us of something we often forget, that we are not separate from the cosmos, but participants in its ongoing drama. Perhaps that is the true gift of the comet swarm. It collapses the distance between the scientific and the sacred, between analysis and awe. It tells us that the universe is not a cold machine, but a stage on which beauty, mystery, and meaning still unfold. For one season in 2025, we will be invited to witness a rare gathering of wanderers, each carrying secrets older than Earth itself, each illuminating the night with borrowed light. When the swarm disperses, the comets will retreat into the dark, some never to return, others bound to swing back centuries from now. But the memory of their gathering will linger. It will remind us that even in an age of satellites and algorithms, the sky can still surprise us with a performance beyond our imagining. As you drift towards sleep, picture that sky, multiple tails arcing across the darkness, Earth bathed in auroras, scientists scrambling for data, children pointing in awe. The universe is alive, and for a brief moment, it has chosen to reveal its abundance all at once. The comet swarm is both a scientific feast and a spiritual gift, a reminder that in the vast silence of space, beauty sometimes comes not alone, but in chorus. Close your eyes and imagine the ocean in the middle of a storm. Waves pile higher and higher, winds howl, and currents twist with unstoppable power. Now replace the seawater with invisible particles, charged and racing across space at nearly 1,000,000 miles per hour. Replace the thunder with magnetic fields groaning and snapping under tension. This is the energy tsunami, an electromagnetic surge unleashed by our sun as it reaches its most restless stage. The term energy tsunami is poetic, but it captures something very real. Solar maximum, the peak of the sun's 11-year cycle, is not just a time of sunspots and flares. It is a reconfiguration of the entire electromagnetic environment surrounding Earth. Sunspot numbers climb, active regions burst with complexity, and magnetic loops on the solar surface stretch and twist until they snap. Each eruption hurls plasma outward, a soup of protons and electrons, guided by tangled magnetic fields. Some of this energy races toward Earth, where our magnetic shield strains to hold it back. We call these events solar storms, coronal mass ejections, high-speed streams, flares, but to the human imagination, they feel like tempests in the sky. The 1859 Carrington event remains the most famous. Telegraph lines burst into flames, auroras painted the skies of the Caribbean, and instruments went wild, with currents no one could explain. If such a storm struck today, it could paralyze satellites, power grids, and communication systems worldwide. And yet, even less severe storms can leave marks. GPS drifting by meters, radio signals fading, transformers humming with hidden stress. Now, add another element. Late 2025 does not bring us only an ordinary solar maximum. It brings a convergence. Multiple comets, including the interstellar Giant 3, I divided by Atlas, dragging vast plasma envelopes into the inner solar system. Each comet's coma acts like a balloon of gas and dust colliding with the solar wind, distorting local magnetic fields. Imagine dropping boulders into a river. The current flows around them, creating eddies, turbulence, and waves downstream. That is what the comets do to the heliosphere, the great solar bubble that surrounds us all. In this environment, the energy tsunami is not a single wave, but a layered storm. The sun's eruptions crash outward. The comet's comas bend and refract the streams. Earth, caught in the middle, becomes both spectator and participant. Our magnetosphere balloons and contracts. Auroras ripple farther south than usual, and geomagnetically induced currents slither through pipelines and cables. Engineers watch nervously. Scientists record data. Ordinary people simply marvel at skies glowing in colors they have never seen before. But the most fascinating question lies beneath our feet. Could this electromagnetic turbulence reach into the crust itself? Some researchers argue, yes. When the magnetosphere is disturbed, currents flow into the ground, currents strong enough to stress conductive rocks and fluids along fault lines. The theory suggests that solar storms might act as a trigger, releasing tectonic stress in regions already poised to break. Skeptics insist the numbers don't add up, that the energy involved is far too small. Still, the timing of some quakes whispers otherwise. The Earth, too, may feel the tsunami. Even if we leave the ground aside, the biological effects are worth pondering. The human body runs on electricity, tiny pulses carried along nerves, delicate rhythms in the brain. Studies show that geomagnetic storms can subtly influence sleep patterns, heart rhythms, even mood. Some people feel restless, others heavy with fatigue during days of high activity. It is as though our own circuits respond to the larger planetary circuit, entrained by forces we scarcely perceive. In times like October 2025, millions may share the same invisible pulse without ever knowing why. The tsunami metaphor reminds us of scale. When a real tsunami crosses the ocean, it carries energy equal to thousands of nuclear weapons. It does not destroy everything in its path. It simply redistributes energy that was already there, unleashed by an earthquake or landslide. Likewise, the solar tsunami is not new energy created from nothing. It is the sun reshaping, reorganizing, and hurling outward the energy it has always carried in its turbulent heart. We are merely caught downstream, small but attentive, trying to interpret the signals. For scientists, this is a gift wrapped in danger. Never before have we had such comprehensive instruments to measure the sun's fury. The Parker Solar Probe skims close to the solar surface, flying through streams of plasma hotter than any furnace on Earth. The solar orbiter watches magnetic fields twisting from a different vantage point. On Earth, magnetometers hum with data, and satellites relay real-time images of solar flares. Each new eruption is recorded, graphed, and modeled, building a clearer picture of how the tsunami grows. But no model can capture it all. The system is too vast, too alive, too complex. Culturally, the energy tsunami carries symbolic weight. Throughout history, auroras were read as omens, red curtains in the sky, presaging war or famine. Today, we understand the physics, but the awe remains. Imagine October skies over mid-latitude cities, suddenly streaked with green and purple light, shimmering curtains reaching the zenith. People will gather, phones in hand, but also simply staring, reminded that the earth is small and the sun is mighty. In that moment, science and myth converge. And perhaps that is the greatest role of the energy tsunami, to awaken a sense of humility. We live in an era where humanity feels powerful, splitting atoms, building networks across the planet, dreaming of colonizing Mars. Yet all it takes is one storm from our star to remind us that we are fragile guests in a larger system. A transformer can be destroyed in seconds. A satellite can be fried in orbit. Even our sleep and thoughts may ripple with electromagnetic whispers from the Sunday. As you drift into rest, picture the invisible sea swelling around you. Imagine Earth as a ship, its magnetic sails straining against gusts of plasma wind, its circuits humming with induced currents. Picture the auroras as foamy crests of waves dancing across the night sky, and feel, for just a moment, the pulse of the energy tsunami as part of your own pulse, binding you to the sun, the earth, and the cosmos beyond. The universe has always had a taste for irony. It speaks not with words but with timing, weaving events together in ways that feel too uncanny to dismiss yet too subtle to prove. On September 10th, 2025, Utah learned this lesson in a way that would ripple across news feeds and quiet conversations alike. At exactly 11:27 a.m. local time, the ground trembled, a modest 4.1 magnitude earthquake along the Wasatch Fault Zone. The tremor was shallow, only 6 kilometers deep, harmless by most geological standards. Residents felt a jolt, a rattle of dishes, a reminder that the mountains around them are not as still as they seem. Then, less than 4 hours later, the state reeled again, not from geology, but from human frailty. A gunman attempted to assassinate a controversial figure during a public gathering, sending shockwaves through an already divided political climate. 2 events. 1 day. Same state. Coincidence? From a scientific perspective, the answer is yes. Earthquakes happen in Utah. They always have. Political violence, tragically, has also become more common in societies under stress. But from a symbolic perspective, the timing was uncanny. A literal fault shook beneath the earth, and then a social fault line cracked in public. Both tremors, one geological, one political, seemed to echo each other, a reminder that instability comes in many forms. Modern chaos, then, is not just about disasters in isolation. It is about the overlay of events, the stacking of crises, until pattern and coincidence blur. Consider the wider context. September had already seen a G3 geomagnetic storm that painted auroras across unexpected latitudes. The sun was restless, spewing streams of high-speed plasma. Seismologists were still passing data from the Kamchatka quakes, one of the most powerful sequences in years. Around the globe, financial markets trembled under uncertainty, while social tensions simmered. In such a charged atmosphere, even unrelated events can feel connected, part of a larger rhythm pulsing through the world. Psychologists tell us that humans are pattern-seeking creatures. Our ancestors survived by recognizing rhythms in the seasons, the cycles of the moon, the migrations of animals. Today, that same instinct makes us see patterns in coincidences: the quake and the shooting, the storm and the unrest. Rationally, we know correlation is not causation, but when the sky burns with auroras, the ground shakes, and headlines scream of chaos, it becomes harder not to feel that threads are woven together. Scientists who explore the frontier of electromagnetic influence on biology add yet another layer. Studies suggest that geomagnetic storms can affect sleep cycles, heart rhythms, even mood. Sensitive individuals report agitation or exhaustion during periods of intense solar activity. Could it be that heightened space weather nudges not only tectonic plates, but also human behavior? The evidence is controversial, but tantalizing. If true, then cosmic storms may influence our societies in ways we barely understand, tiny shifts that ripple into major consequences when tensions are already high. Take, for example, the coincidence of widespread protests during geomagnetic storms earlier that year. The grievances were real, rooted in economics, justice, and politics. But the timing, some researchers argue, may not have been purely random. If millions of nervous systems are subtly affected by electromagnetic fluctuations, perhaps moods sharpen, tempers shorten, and collective behavior tilts toward unrest. The Earth, then, would not be a passive stage, but an active participant, its electrical heartbeat influencing the dramas played upon it. Of course, mainstream science remains cautious. Statistical noise is tricky, and extraordinary claims demand extraordinary evidence. Most seismologists, political analysts, and physicists will tell you plainly: quakes are tectonic, unrest is social, and storms are solar. Yet even they admit that the convergence of so many events in late 2025 creates an unusual natural experiment. Never before has humanity had such dense monitoring of space, weather, seismic activity, and social behavior all at once. Data will be studied for years to come, but beyond the graphs and statistics lies the human experience, the feeling of living through modern chaos. Imagine being in Salt Lake City that day. First, the ground shakes, rattling windows. Hours later, sirens wail downtown as news spreads of gunfire at a rally. Meanwhile, social media fills with shimmering videos of auroras dancing far south of their usual haunts. For ordinary people, the world feels charged, uncanny, alive with hidden connections. This is where myth and science begin to overlap. Ancient traditions often linked celestial events with earthly upheavals. A comet in the sky meant kings would fall. An eclipse foretold famine. We dismissed those myths as superstition, yet our modern narratives are not so different. When the sun surges, when the earth quakes, when societies fracture, we too search for meaning. The difference is that now we have satellites, sensors, and statistics. But the instinct, the need to weave chaos into story, remains unchanged. Modern chaos is not simply danger. It is also opportunity. Chaos reminds us that stability is fragile, that certainty is an illusion. It urges us to prepare, to adapt, to rethink our assumptions. The quake in Utah was small, but it was a rehearsal for larger ones sure to come. The assassination attempt, tragic though it was, forced a society to confront its divisions. The geomagnetic storm, disruptive to machines, reminded us that our technology rides on currents shaped by the Sunday chaos, breaks routines, but also opens eyes. As you drift into sleep, let yourself imagine the planet, not as a quiet rock, but as a living participant in cosmic dramas. Faults shift, storms rage, societies tremble. None of these alone defines the future, but together they weave the fabric of modern chaos. The lesson is not despair, but awareness. Life unfolds in layers, visible and invisible, predictable and uncanny. When they converge, we feel the ground move, literally and metaphorically. So breathe deeply. The chaos of September 2025 is not an ending but a mirror, reflecting the truth that we live in a web of forces larger than ourselves. The sun, the earth, and humanity all vibrate together, sometimes harmoniously, sometimes discordantly. And in those moments when everything seems to align in uncanny fashion, we are reminded that order and disorder are not opposites but partners in the same cosmic dance. When the sky fills with signs, humanity begins to dream in archetypes. It has always been this way. The ancients watched comets and eclipses, not as random events, but as messages woven into the great story of existence. They saw in the heavens the same patterns that shape our lives, beginnings, endings, and the painful but necessary space in between. As October 2025 approaches, with its comets, storms, and convergences, we too find ourselves standing at the threshold of an archetypal shift, a moment when the language of death and rebirth feels impossible to ignore. Death, in this context, is not merely the end of life, but the dissolution of patterns. It is the cracking of old shells, the collapse of structures that once gave us security. In nature, seeds rot before they sprout. Stars die before their elements seed new galaxies. Our personal lives, too, cycle through endings, the closing of relationships, the loss of certainties, the unraveling of identities. Collectively, societies experience the same rhythm. Economies falter, governments fall, belief systems lose their grip. These endings are painful, but they are not mistakes. They are part of the archetype, the death that precedes rebirth. The rebirth, however, is not guaranteed. It requires choice, attention, and radical responsibility. A forest burned by wildfire may regrow, but only if conditions allow. Similarly, a society fractured by crisis may collapse further, or it may use the rupture to imagine something new. What determines the outcome is not the chaos itself, but how we respond to it. Here lies the heart of the archetypal shift, the invitation for humanity to take responsibility, not for the storms or the quakes, but for the way we meet them. Radical responsibility is a demanding teacher. It does not permit us to hide behind blame. It asks us to admit that, though we do not control what happens, we do control our response. It requires courage to acknowledge that our choices ripple outward, shaping not only our own lives, but the collective field. To embrace this responsibility is to step into maturity as a species. It is to say, yes, the sun flares, the earth quakes, societies tremble, but still we choose how to stand in the midst of it. Think of the archetypes that recur in myth. Osiris dismembered before rising anew. The phoenix reduced to ash before taking flight again. Christ crucified before resurrection. In each story, death is not failure, but initiation. The rebirth does not erase the pain, it transforms it. The old self, the old world, cannot return. Something different emerges, fragile at first, then strong. Our moment in history echoes these myths, not in detail, but in pattern. The cosmos is staging a drama of dissolution and potential renewal. And humanity is both actor and audience. The symbolism of the October new moon in Virgo adds another layer. Virgo, the harvester, is associated with discernment and preparation. A harvest is both an ending and a beginning, the culmination of growth and the clearing of fields for what comes next. In this season, the comets blaze, the sun roars, and earth quivers. It feels almost scripted, the old being harvested, the new waiting to be sown. Yet no script dictates our choices. The archetype invites, but it does not compel. Shadow work becomes essential here. When societies fracture, it is easy to project our fears and anger outward, to demonize the other side, to insist that the darkness belongs to them, not us. But archetypal death and rebirth demand honesty. They require us to see that the shadows we fight outside are often the same ones we hide inside. Violence in the streets mirrors unacknowledged aggression in our own hearts. Polarization on the news mirrors our own refusal to listen. To take radical responsibility is to reclaim these shadows, to integrate them rather than hurl them outward as weapons. Forgiveness, too, becomes part of the shift. Not the cheap forgiveness that excuses injustice, but the deeper kind that releases us from the poison of resentment. To forgive is to unclench, to stop feeding cycles of retaliation. It is not about forgetting, it is about choosing not to be defined by wounds. In archetypal language, forgiveness is one of the seeds of rebirth, a quiet act of courage that clears space for new growth. All of this may sound abstract until we place it within the tangible context of 2025. Solar storms will surge, auroras will flare, quakes may rumble, and political tempests will erupt. These are real, measurable events. But alongside them will unfold the inner dimension. How we interpret, how we respond, how we carry ourselves through the storm. The archetypal shift is not only cosmic, it is personal. Each of us is invited to let something die, something that no longer serves, so that something truer may be born. Picture yourself lying under the October sky. Comet tails glow faintly above, like silver scars across the dark. The moon is new, invisible, its presence felt only in the darkening of the night. Somewhere on Earth, the ground quakes. Somewhere else, people march, argue, cry, or celebrate. In that moment, you are part of it all. The archetype is not distant, it is in you. Your fears, your choices, your willingness to take responsibility, they matter. They shape the rebirth that will follow the death. The comfort, if we can call it that, is that this rhythm is older than us, older than humanity, older even than Earth. Stars have died and been reborn countless times. Civilizations have risen and fallen. Each collapse feels like the end, but each end has seeded what comes next. We are part of a continuity far greater than our lifetimes. To embrace the archetypal shift is to surrender to this rhythm, to let go of the illusion of permanence and step into the dance of transformation. So breathe in the chaos, the endings, the uncertainties. Let them remind you that stability is never absolute, that control is never complete. Breathe out responsibility, compassion, and courage. These are the gifts that carry us through death into rebirth. This is the invitation of the archetypal shift. As you drift towards sleep, remember, the cosmos does not ask us to stop the storms or silence the quakes. It asks us to meet them awake, to take radical responsibility for how we live within them. Death is not the end. Rebirth is waiting. The only question is whether we will choose to rise. Imagine standing barefoot on the ground after a summer storm. The air crackles with static. The clouds still grumble with distant thunder, and every hair on your arm rises as if listening to an invisible song. This, in miniature, is what our entire planet experiences every day. The hum of an electric symphony played on a global scale. Scientists call it the global electric circuit, but the term symphony may capture its essence more fully, for it is not just a current, but a rhythm, a melody connecting sky, ground, and space. At its simplest, the circuit works like this. Thunderstorms charge the upper atmosphere. Lightning bolts act as sudden drumbeats of discharge, and the ionosphere above, a thin veil of charged particles, closes the loop. Each thunderstorm is like a violin in an orchestra, contributing its own part to the greater harmony. At any given moment, Nearly 2,000 thunderstorms rage across Earth, each producing flashes of lightning. Those flashes are not only bursts of light and sound, but also notes in the planet's electric song. When you step back and view it on a planetary scale, the effect is astonishing. A constant flow of electricity, about 1,800 amps at any given time, circulates between ground and sky. This current is subtle enough not to shock us, yet strong enough to knit the planet into a coherent whole. It is, in a sense, Earth's heartbeat. But unlike a simple pulse, it is layered, responsive, and influenced by forces far beyond the weather. During quiet solar days, the symphony plays softly, a steady background hum. But when the sun awakens, when solar storms sweep across the heliosphere, the symphony crescendos. The magnetosphere shudders, the ionosphere crackles, and new harmonics appear in the global circuit. Instruments, designed to measure these shifts, register changes in resonance, low-frequency electromagnetic waves, known as Schumann, resonances that echo around the planet between the ground and the ionosphere. Some researchers call them Earth's heartbeat frequencies. They are always present, but they grow louder during storms, both earthly and solar. Here, the metaphor of a symphony becomes even more striking. Imagine a vast orchestra with three sections: Earth itself, with its thunderstorms and quakes, the Sun, with its flares and winds, and the interstellar guests, like three, I divided by Atlas, dragging plasma comas into the mix. Each plays its part, and though we may not yet understand the score, we can feel the music in subtle ways. Auroras shimmer like violins, lightning crackles like percussion, solar storms roar like brass, and comets, with their giant ion tails, seem like sweeping cellos, bending the melody in unfamiliar ways. But what does this mean for us? At the level of daily life, it is easy to forget we live inside an electrical instrument. Yet subtle hints remind us. Geomagnetic storms can induce currents in pipelines, corroding them faster than expected. They can whisper through power grids, adding stresses invisible until transformers fail. They can disrupt GPS and radio, leaving pilots and sailors momentarily blind. These are the mechanical notes of the symphony, the ones that touch technology. And then there are the biological notes, more mysterious, but perhaps more profound. The human body operates on electrical signals, neurons firing in the brain, heart cells pulsing in rhythm. Some scientists have wondered whether Schumann resonances, the low-frequency hum of the Earth, might sync with brain waves, subtly influencing sleep, mood, and cognition. The evidence is tentative, yet compelling enough that studies continue. Could it be that our minds, too, are instruments in the global symphony, resonating faintly with the planet itself? If so, then the great cosmic events of 2025, the geomagnetic storms, the comet swarm, the awakening sun, may affect us in ways both obvious and hidden. Not only through auroras dazzling the sky, or blackouts rippling across power grids, but through subtle shifts in how we feel, think, and connect. Modern chaos may not be entirely ours. Some of it may be the music of the cosmos playing through us. To imagine Earth as part of a global electric symphony is to blur the line between physics and philosophy. For physics tells us the mechanics. Thunderstorms generate currents. The ionosphere closes the loop. Solar storms add resonance. But philosophy asks, what does it mean to live inside a song? Are we passive listeners or active participants? Can we choose to harmonize with the music? Or do we simply ride along as the notes crash and swell? Perhaps the truth lies somewhere in between. We cannot control the sun nor silence the storms, but we can choose how to respond, whether to resist the rhythm or to dance with it. Radical responsibility, as we saw before, means acknowledging our role in shaping meaning, even when we cannot shape events. The symphony will play whether we notice it or not. To listen, to align ourselves with its pulse, is to live more consciously within the cosmic whole. Imagine again lying down beneath the night sky. A storm flashes on the horizon. Far above, the ionosphere glows faintly, electrified by currents you cannot see. Beyond it, the solar wind streams past, a river of charged particles carrying echoes from the Sunday, and somewhere in the darkness, comets flare with alien ices, adding their chords to the music. You are not separate from this song. Your own heartbeat, electrical and rhythmic, is another instrument playing along. The global electric symphony is not only science, it is also story. It reminds us that the universe is not inert machinery, but dynamic resonance. It is not silence punctuated by accidents, but music unfolding through time. And as the symphony swells in late 2025, with the sun at peak and comets ablaze, we are invited to listen more deeply than ever before. So close your eyes. Feel the hum beneath your feet, the pulse in your chest, the currents whispering through the air. Let yourself drift, not into silence, but into the music that has always surrounded you. For the earth sings, the sun sings, and tonight, if you are quiet enough, you might just hear the chorus of the cosmos itself. Some patterns hide in plain sight, waiting for a careful observer to notice them. Others are more elusive, surfacing only in the margins where chance and meaning blur. This is the territory of synchrony, the mysterious timing of events that feel connected, even when science insists they are not. Late 2025 is rich with such shadows of synchrony, quakes and storms arriving within days of each other, comets converging as though on cue, societies unraveling just as the heavens erupt in auroras. Coincidence, perhaps, but when coincidence stacks upon coincidence, the human mind leans in, searching for threads. Synchronicity, a term popularized by Carl Jung, was meant to describe meaningful coincidences, moments when inner states and outer events align in ways that defy logic but feel undeniable. Jung did not argue that causal forces were at play. Rather, he suggested that psyche and cosmos could mirror one another, like two dancers following the same rhythm. In the shadows of synchrony, we glimpse such mirrors. The timing of Utah's earthquake and political violence, the arrival of cometary swarms alongside solar storms, the clustering of global protests during geomagnetic upheaval, each by itself explainable, together uncanny. Science rightly demands caution. Statistical noise is deceptive. With billions of events happening on Earth every day, some are bound to align by chance. Yet synchrony is not about proof, it is about perception. When the sky flares with light and the ground shakes soon after, we feel connected to something larger, whether or not equations support it. That feeling is its own phenomenon, shaping culture, myth, and behavior. It is why ancient civilizations saw omens in comets and eclipses. It is why even now, headlines about cosmic coincidence spread so quickly. But what if synchrony is more than perception? Some researchers propose subtle mechanisms that might link seemingly separate events. For instance, solar storms influencing not only Earth's magnetosphere, but also human physiology, or electromagnetic currents nudging fault lines closer to failure. The connections may be weak, probabilistic, and easily lost in noise, but they could still exist. In complex systems, small nudges at the right time can produce outsized effects. Synchrony, then, would not be magic, but resonance systems vibrating together when conditions align. Consider how resonance works. A singer can shatter a glass, not by sheer volume, but by matching its natural frequency. Push a child on a swing at just the right moment, and small pushes create soaring arcs. The universe, too, may harbor resonances. Cycles of the sun, rhythms of the earth, pulses of human society. When those cycles overlap, synchrony emerges. Not causation, but alignment. Not control, but harmony. The shadows of synchrony remind us that timing can matter as much as force. History is full of strange alignments. The great Lisbon earthquake of 1755 struck on All Saints' Day, toppling churches full of worshippers and shaking Europe's faith in divine order. The Tunguska explosion of 1908 flattened forests in Siberia on the very morning that a spiritualist in London predicted a cosmic fire. The September 11th attacks in 2001 coincided with a solar maximum, when geomagnetic disturbances were unusually common. None of these connections prove cause, yet they echo in cultural memory precisely because timing magnifies meaning. October 2025 is shaping into another such moment. Comets blaze, the sunstorms, earthquakes, and societies fracture all in overlapping rhythms. Some will dismiss it as coincidence, others will see it as prophecy. Both reactions miss the deeper invitation. The shadows of synchrony are not about proving causation, but about noticing connection. They remind us that we are participants in a universe alive with rhythm, not isolated dots in a meaningless void. Synchrony also asks us to reflect inward. When outer events seem to mirror our inner state, what message might they carry? If the earth shakes as we feel shaken, if the sky erupts as tempers flare, perhaps the universe is not mocking us, but calling us to awareness. The shadows become a mirror, showing us what we have not fully acknowledged. Jung believed such coincidences could guide individuals through transformation. Perhaps they can guide societies as well. Of course, the danger is over-interpretation. Humans can drown in pattern-seeking, mistaking every coincidence for destiny, every echo for a prophecy. Balance is required. Skepticism to guard against delusion, openness to appreciate mystery. The shadows of synchrony thrive in that balance, where science's caution meets philosophy's wonder. Imagine lying beneath the October sky, comets streaking above, auroras dancing at the horizon. Your phone buzzes with news of an earthquake, a political crisis, or a market crash. In that moment, you feel the rhythm, outer and inner worlds moving together. Rationally, you may know the links are tenuous, yet, emotionally, the synchrony is undeniable, and perhaps that feeling matters. It shapes how we interpret events, how we find meaning in chaos, how we connect our lives to the wider cosmos. The beauty of synchrony is that it does not demand explanation. It asks only to be noticed. Like the faint harmony of two notes blending, it enriches the experience without requiring proof. When comets and storms and quakes converge, we are reminded that life unfolds not only through causes, but also through patterns, some visible, some hidden. As you drift towards sleep, imagine the universe as a great clock, not rigid and mechanical, but alive with rhythms. Sometimes the hands line up, striking moments that feel heavy with meaning. Sometimes they drift apart, leaving only background hum. The shadows of synchrony are those moments of alignment, when everything seems to move together in a hidden dance. Whether coincidence or resonance, they remind us that we are part of a larger story written in the language of time itself. Every stone carries a memory. Pick up a pebble on a riverbank, and you are holding a fragment of mountain, a witness to rain and glaciers, a record of forces too slow to see. Now lift your gaze upward. The comets, asteroids, and dust drifting through space are also stones of memory, but on a cosmic scale. They carry the history of stars, the chemistry of nurseries long vanished, the frozen breath of worlds that never were. To watch the comets of 2025 sweep through the solar system is to witness not just celestial fireworks, but the resurfacing of memories written billions of years ago. Comets are sometimes called time capsules. Within their icy nuclei lie molecules that formed before Earth even existed water, carbon compounds, exotic ices that preserve the chemistry of the early galaxy. When sunlight warms them, those molecules sublimate, releasing a haze that becomes the coma and tail. In that shimmering glow, telescopes capture spectral fingerprints of hydrogen, oxygen, carbon dioxide, even amino acid precursors. It is as if the comet opens its diary, revealing pages of ancient history in luminous script. The interstellar visitor 3, I divided by Atlas, is even more extraordinary. Unlike local comets, which circle the Sun in predictable loops, Atlas comes from elsewhere, perhaps a stellar nursery dissolved long ago, perhaps a system shattered by gravitational upheaval. Its path is hyperbolic, ensuring it will pass through once and never return. That means the material it carries is pristine, untouched by billions of years of solar radiation. Its coma, half the diameter of the Sun, is a vast library of alien chemistry, a cosmic memory arriving at our doorstep. Astronomers have long dreamed of such opportunities. In 2017, the first interstellar visitor, Oumuamua, passed by too quickly for detailed study, leaving us with tantalizing questions. In 2019, Borisov followed, a more ordinary comet but still a messenger from afar. Now, in 2025, Atlas lingers, glowing, releasing its secrets slowly enough for our instruments to listen. For scientists, this is not merely observation, it is archaeology on a galactic scale. Yet cosmic memory is not just about molecules, it is also about patterns that repeat across time. Consider the cycles of solar activity, the surging and fading of sunspots, the pulsing of auroras. Each cycle is a kind of memory, our star's way of recalling its own rhythms. Earth, too, carries memory in its rocks. Magnetic fields frozen in lava, recording reversals of polarity over millions of years. Even earthquakes, sudden as they seem, are expressions of long memory fault lines storing centuries of stress before releasing it in seconds. When these layers of memory converge cosmic, solar, terrestrial, we feel something uncanny. The quakes of Kamchatka, the auroras of September, the swarm of comets, they are not isolated accidents. They are memories surfacing together, resonating like overlapping chords. The universe seems to remind us that nothing is ever truly lost. Energy, matter, pattern, all are preserved, waiting for the right conditions to reappear. Humans, too, are creatures of memory. Our brains store experiences, our cultures preserve myths, our civilizations leave ruins. The sight of a comet awakens something ancient within us. We may no longer believe, as the Babylonians did, that comets foretell the death of kings, but we still feel awe, reverence, even unease. The memory of fear persists, encoded in our collective psyche. At the same time, the memory of wonder stirs. The knowledge that comets may have delivered water and organic molecules to early Earth, seeding the possibility of life. In their tales we see both dread and origin, ending and beginning. The idea of cosmic memory extends further still. Some philosophers suggest that the universe itself is a kind of memory system. Every interaction leaves an imprint. Every particle collision, every photon absorbed or emitted, writes data into the structure of reality. The cosmos, then, is not a stage where events vanish once played. It is a book that records itself, endlessly writing and rewriting, with comets as punctuation marks across its pages. To sleep under the October sky in 2025 is to lie within this memory. Above, Atlas glows with the chemistry of another star. Swan stretches a luminous tail across binoculars. Lemon brightens night by night. Each is a storyteller, carrying archives older than humanity. Below, Earth hums with its own memories. Quakes reverberating through rock, auroras flickering through atmosphere, cultures recalling myths that once tied sky and fate together. You, too, are part of this chain, your body composed of atoms forged in ancient stars, your thoughts shaped by ancestral memories. Cosmic memory is not passive. It shapes the future as much as it recalls the past. The ice in a comet's coma, when it sublimates, alters the solar wind around it, creating waves and turbulence that ripple outward. A quake reshapes coastlines, which in turn influence human migration, which in turn reshapes culture. Memories are seeds, and they germinate. The universe does not merely store. It evolves through what it remembers. This perspective invites humility. Our technologies, our monuments, our headlines may feel urgent and unprecedented. Yet comets remind us that history extends far beyond human scales. The rock in your hand may be 1 billion years old. The carbon in your breath may have traveled through multiple stars. The memories we carry are not only personal or cultural, but cosmic. We are pages in a book written across galaxies. And yet, this realization is not diminishing. It is comforting. To belong to cosmic memory is to know that we are never alone, never rootless. The universe remembers us, just as we remember it. Every heartbeat, every word, every glance at the night sky is inscribed somewhere, woven into the electric and gravitational fabric. Even if forgotten by others, even if erased by time, it remains in the greater memory of existence. As you prepare for rest, imagine yourself as both witness and participant in this symphony of memory. Picture Atlas, drifting silently, its coma glowing with alien chemistry. Picture Earth beneath it, humming with resonances of past quakes and storms. Picture yourself lying there, small yet infinite, remembering and being remembered. In this vast archive, nothing is wasted. The universe keeps every note. Cosmic memory whispers that the past is never gone, only transformed. And perhaps that is the secret we most need in chaotic times. Endings are not erasures, but transitions. What was is still here, carried forward in new forms. We are not the first to face upheaval, nor will we be the last. But we, too, are part of the memory that will echo long after we are gone. There is a moment in every orbit when a comet faces its greatest trial. Perihelion, the instant of closest approach to the Sunday. For months, sometimes years, the comet drifts inward, its icy nucleus waking slowly under the growing heat. But perihelion is different. It is the threshold where forces peak, where survival is uncertain, and where beauty and destruction are indistinguishable. For 3, I divided by Atlas, October 30th, 2025, will mark such a moment. It will come within 1.4 astronomical units of the Sun farther than Earth, but close enough to transform it into something extraordinary. To imagine this passage, picture a mountain of ice and dust, only a few kilometers wide, wrapped in a coma larger than the Sunday. That mountain has traveled for eons, through interstellar space, carrying chemistry from a distant nursery. Now it plunges into a storm of radiation and plasma. Solar photons strike its surface, vaporizing layers of ice. Jets of gas burst forth, carrying dust into space. The coma swells, rippling with light and magnetism. Tails, one of dust, one of ions, stream outward for millions of kilometers, banners of survival in a hostile wind. For astronomers, perihelion is a time of revelation. Spectrometers on Earth and in orbit record the gases released: carbon dioxide, carbon monoxide, exotic organics, each line in the spectrum a clue to the comet's birthplace. Radio telescopes monitor the interaction between the coma and the solar wind, capturing electromagnetic murmurs otherwise invisible. X-ray observatories detect photons created when solar wind particles collide with neutral atoms in the coma. The comet, for a brief window, becomes both a victim of the sun's fury and a laboratory for plasma physics on an unimaginable scale. But for the comet itself, perihelion is a test of endurance. Some comets do not survive. Tidal forces pull them apart, fragmenting them into cascades of debris. Thermal stress cracks them, splitting nuclei into smaller shards that continue along separate paths. Even without complete destruction, comets lose mass rapidly at perihelion, shedding thousands of tons of material every hour. Atlas, with its volatile ices and hyperactive coma, may emerge transformed, diminished, or even gone. Observers around the world will watch anxiously, wondering whether this interstellar guest will survive its fiery encounter or dissolve into memory. The symbolism of perihelion is powerful. It is the archetype of crisis and transformation, the point where pressure peaks and outcomes are decided. Humans, too, know perihelion moments, illnesses that bring us to the edge, crises that strip us bare, trials that demand we surrender or grow. Like comets, we emerge, changed, sometimes scarred, sometimes radiant, but never the same. Atlas's passage is not only astronomy, it is metaphor. A messenger from beyond the stars is showing us what it means to endure fire and keep moving forward. The sun, of course, is not passive. It is itself at a peak of activity, with solar cycle 25 approaching maximum. Coronal mass ejections blast plasma outward. Coronal holes open, releasing high-speed streams. Magnetic fields twist and reconnect, hurling particles into space at nearly the speed of light. For Atlas, this environment is both stage and antagonist. Its coma does not simply evaporate. It interacts, reshapes, resonates. Shock waves ripple through the plasma, forming bow structures around the comet. Magnetic field lines bend, dance, and snap. The encounter is not destruction alone. It is dialogue, an electrical conversation between star and wanderer. And Earth, though millions of kilometers away, is part of this dialogue. The same solar storms that buffet Atlas also buffet us. Our magnetosphere shudders. Our skies ignite with auroras. Perhaps, if the speculative theories prove true, our ground trembles too, faults responding to subtle currents. In this sense, perihelion is not just the comet's threshold, but ours. We, too, feel the sun's fury, though in quieter, slower ways. The days around October 30th will be dense with observation. Amateur astronomers will peer through telescopes, hoping to glimpse tails stretching across the sky. Space agencies will coordinate, aiming instruments for maximum coverage. News outlets will amplify dramatic images, auroras and comas splashed across screens. And somewhere deep inside, people will feel something ancient, awe. A reminder that, for all our technology, we remain small beneath the sun and the visitors it attracts. The mystery, of course, is what comes after. If Atlas survives, it will retreat outward, fading as it goes, carrying with it the scars of perihelion. It may never return, bound on a hyperbolic orbit into interstellar space. Its visit would then be a once-in-a-species opportunity, a fleeting intersection between two star systems. If it does not survive, its fragments may disperse, creating trails of dust that could intersect Earth's orbit in years to come, producing meteor showers of alien origin. Either way, memory will remain data recorded, myths written, stories told. But the deeper meaning of perihelion lies in its universality. Every system, from comets to civilizations, faces thresholds. Pressures build until they cannot be ignored. Change becomes inevitable. Sometimes the result is collapse. Sometimes it is renewal. What matters is not the avoidance of perihelion, but the courage to pass through it. For in fire, new forms emerge. In crisis, new paths open. As you lie back tonight, let the metaphor settle in. Imagine yourself as a comet, carrying memories of your past, drifting through darkness. Ahead lies the sun trial, heat, transformation. You cannot avoid it. Your path bends inexorably toward it. Yet within that trial lies the chance to shine, to release hidden treasures, to expand into radiance. Perihelion is not an end, but a threshold, a reminder that the brightest displays often arise from the harshest encounters. So rest easy, knowing that even as Atlas faces its trial, it is not alone. The Earth watches, the sun sings, and the cosmos records. Every perihelion, great or small, becomes part of a larger story. And when dawn breaks after the fire, what remains is not only survival but memory light carried forward into the next journey. When a comet passes perihelion, the story does not end. In some ways, it only begins. The blazing encounter with the sun is a climax, but what follows its fading light, its fragments, its trails through space, are the echoes that ripple long after the curtain falls. For 3, I divided by Atlas the days and weeks after October 30th, 2025, will be a time of revelation. Survival or disintegration, glory or ghost, its aftermath will shape not only our observations, but also our imaginations. Suppose Atlas survives. Its nucleus, though battered, continues onward, trailing a vast plume of dust and gas. Its coma may shrink, but the memory of its brilliance lingers in the instruments of telescopes, the photographs of amateurs, the minds of those who looked up. Scientists will study the changes, the new cracks on its surface, the altered spin rate, the chemistry of gases released under solar fire. Each detail becomes a note in the comet's biography, a record of how alien matter endured the furnace of our star. Survival, in this sense, is not just endurance but transformation. Atlas will never be the same comet again. Perihelion changes everything. Now imagine the other outcome. Atlas does not hold. Its fragile nucleus fractures, splitting into shards that scatter like embers in a cosmic wind. To the naked eye, it might fade quickly, its brilliance dissipating into invisibility. But to astronomers, the fragments are treasure. Dust trails spread across orbits, leaving behind debris streams that may one day intersect Earth, producing meteor showers unlike any we have seen shooting stars from another star system. Even in death, the comet gives, scattering seeds of memory that may light our skies for centuries. Whichever path Atlas takes, echoes will follow. Meteor streams, chemical signatures, data archived in observatories worldwide, all of these are fragments of its legacy. For humanity, the echo is also psychological. The sight of a glowing coma, half the size of the sun, the knowledge that it came from beyond, the speculation about its effects, all of this becomes part of cultural memory. Children born in 2025 may one day recall that their parents spoke of the great interstellar comet, the way older generations recall Halley's or Shoemaker, Levy. The echo is not only in the sky, it is in us. Aftermath also belongs to Earth itself. The sun, restless in its maximum, will continue to hurl storms outward. Some may strike us, creating auroras and blackouts. Others may graze the fading coma of Atlas, carving structures into its tail. Earthquakes may or may not align with these disturbances, but the debates will persist. Are the quakes and storms linked or merely coincidental? Data collected during this window will feed research for decades, testing hypotheses about electromagnetic triggers, space weather correlations, and planetary sensitivity. Even if science never proves causation, the echoes of these questions will remain, challenging us to expand our frameworks. Echoes ripple through culture, too. Poets will write of a comet that came and vanished, Musicians may name albums after it. Conspiracy theories will spread, claiming the comet was a sign, a warning, perhaps even an engineered visitor. Documentaries will air, blending awe with speculation. In the collective psyche, Atlas becomes more than an object. It becomes a symbol, a story, onto which humanity projects its fears, hopes, and philosophies. The comet's aftermath is not just dust in space, but resonance in human minds. There is also a subtler echo, the inner kind. Watching a comet fade reminds us of impermanence. What blazed bright one night may be gone the next. We too shine briefly, leave trails, then vanish. Yet, like comets, we leave echoes, children, memories, art, and the unseen ripples of our choices. Atlas, in this sense, is a mirror. Its aftermath is our aftermath. Its fading glow whispers to us. Everything passes, but nothing is lost. Consider the science of echoes. When a comet passes perihelion, dust particles remain behind, spread along its orbit. Each particle reflects sunlight faintly, becoming part of the zodiacal light that sometimes glows along the horizon before dawn. These faint glows are echoes, small but persistent, reminders of larger events. In the same way, Atlas will leave behind traces we may not notice directly, but which alter the texture of our skies for years. Even fragments too small to see may carry the chemistry of alien stars into our solar system, mingling with the dust we breathe, the soil that grows our food, cosmic echoes, entering our bodies silently. The aftermath is also a question of perspective. For earthbound observers, Atlas appears to fade, to leave. But in reality, it continues onward, outward, on its hyperbolic trajectory. It is not dying, it is departing. To us, its brilliance is gone. To the galaxy, it travels on. Perhaps, in 10,000 years, it will pass another star, another planet, another species looking upward in wonder. For them, Atlas will be a messenger from our corner of the Milky Way, carrying with it faint chemical fingerprints of our Sunday. The comet's journey is longer than our history. Its echoes broader than our imagination. As you lie in the quiet of night, think of these echoes. Some are grand meteor showers, painting the sky, auroras shimmering across continents. Some are subtle data archived in servers, spectral lines hidden in graphs, cultural myths whispered to children. And some are intimate, the way you feel, the way you remember, the way you carry the story of a comet that once passed close to the sun while you were alive. Aftermath is never silent. It hums, like the fading resonance of a bell long after the strike. Echoes remind us that nothing truly ends. It only changes form. Atlas, whether whole or shattered, will become part of the ongoing memory of the universe, and so will we. Every story needs a final breath, a moment where the words fall silent but their meaning lingers like the afterglow of a comet. Tonight, that breath is our lullaby, a last song woven from the quakes of earth, the winds of the sun, and the wandering veil of three, divided by Atlas. It is not a lullaby sung to children, but to humanity itself, inviting us to rest in the vastness we inhabit, to let go of fear, and to drift into sleep as part of the cosmic rhythm. The lullaby begins with Earth. Our planet hums with quiet music, tectonic plates shifting, oceans sighing, winds carving valleys. We rarely notice this music until it crescendos into quakes or storms, but it is always there. Imagine lying down and pressing your ear against the soil. You would not hear silence, but vibrations. The ground is alive. Every footstep you take is answered by ancient rock moving beneath, by magma stirring deep within. The lullaby of Earth is steady, low, and patient. It has been singing for billions of years, and it will continue long after we are gone. Above, the sun adds its own verse. Its light is not only brightness, It is heartbeat. Solar flares crack like cymbals, solar winds flow like violins, and coronal mass ejections thrum like drums. Each particle hurled into space is part of a symphony that reaches Earth in whispers of aurora, in flickers of satellites, in subtle pulls on our magnetosphere. The lullaby of the sun is wilder, more restless, sometimes serene, sometimes thunderous. Yet it too is music, carrying us through seasons and centuries, wrapping us in warmth. And between Earth and Sun floats Atlas, our interstellar guest. It does not speak in words, but in light diffused across millions of kilometers. Its veil is a chorus of dust, its tail a harmony drawn by the solar wind. Atlas sings softly, a voice from another star system, reminding us that the universe is larger than our fears, richer than our doubts. Its song is faint, but it joins the choir, Earth's bass, the sun's instruments, the comet's whisper. Together they create a lullaby more profound than any we could compose alone. The last lullaby is not about answers. It is about surrender. In science, we often seek certainty numbers, proofs, causes, but in life, and especially in sleep, we accept not knowing. The child does not demand to understand every note of the lullaby. They simply let it wash over them. In the same way, we need not untangle every mystery of quakes and storms, every origin of comets. We can rest inside the unknown, letting wonder carry us instead of fear. Consider how lullabies work. They are repetitive, gentle, predictable, creating a rhythm that comforts. The universe, too, has its rhythms. Day follows night, tides follow the moon, solar cycles wax and wane, and even interstellar visitors trace paths that may never return, but still obey physics. Our lives fit inside these patterns. Breathing in and out is our personal lullaby, a rhythm that joins the larger music. Tonight, as you listen, notice your own breath, how it rises and falls like waves, how it anchors you inside the vast ocean of time. The lullaby also reminds us of connection. No lullaby is sung alone. It is always meant for another. Earth's quakes are not messages, yet they connect us to geology's history. The sun's storms are not aimed at us, yet they touch our technology and our skies. Atlas does not know us, yet it carries its story into our system, and we receive it as if it were written for us. In this way, the lullaby is not private but shared. To dream beneath it is to participate in the universe's song. What happens when the lullaby ends? In truth, it never does. The song continues, even when we no longer listen. Long after Atlas departs, long after the storms fade, the earth will continue to hum. Our children and their children will hear other verses, different comets, different quakes, different auroras. The lullaby is continuous, shifting voices, but keeping the rhythm. We are simply one generation of listeners, passing on the memory of what we heard. Perhaps this is why bedtime stories matter. They teach us how to listen, how to imagine beyond ourselves. They are small rehearsals for awe. When we tell of quakes and comets, we are not only sharing facts, but teaching the next generation how to rest inside mystery. Sleep becomes practice for life itself, trusting the unknown, releasing control, and joining a rhythm greater than our own heartbeat. Picture this as you drift. The earth beneath you steady, despite its tremors. The sun above you steady, despite its tempests. The comet beside you steady, despite its fleeting visit. You are safe in their company, wrapped in a blanket woven from stone, light, and dust. The last lullaby is playing not through speakers, not through voices, but through the very fabric of the cosmos. You are part of it, and so, close your eyes. Let Earth's bass soothe you. Let the sun's instruments lull you. Let Atlas's whisper carry you. Do not fear the quakes. They are part of Earth's music. Do not fear the storms. They are part of the sun's song. Do not fear the comets. They are visitors reminding us that stories never end. Fear nothing tonight. Sleep, and let the last lullaby be enough. For in the end, the universe sings not to frighten us, but to cradle us. Its quakes are drumbeats, its storms are choruses, its comets are verses. Together, they form a song older than humanity, yet always new. Tonight, you hear it. Tomorrow, you may remember only fragments. But in sleep, you are immersed in its fullness, resting in a music that has no final note. The last lullaby continues, long after you close this story. It continues in the silence of the night, in the rhythms of your breathing, in the spinning of the earth and the shining of the stars. You do not have to hold it, it holds you. Sleep now, and let the music carry you into dreams.